by Dr. Chatterjee. And in the afternoon, we have a lecture from Dr. B.S. Pabla, who is professor in Mechanical Engineering Department on automation in industries. And tomorrow, the whole Tuesday, it is dedicated to PLC. I'll be taking up the session on PLC and its industrial applications and also ladder logic programming of PLC. Because as we know that PLC is a very indispensable part of industrial automation. So in the afternoon, we have called an expert, Mr. Arik Khanna. He'll be giving you details about the hardware interface. He's also bringing along one Mitsubishi PLC, and he'll be demonstrating various practicals on that PLC. On Wednesday, we have expert from his senior scientist, Dr. Baban Kumar from CSIU. He'll be telling you about his project, that is tractor-mounted automation in precision farming. Like what is the role of automation in the precision agriculture. And in the same day at 11:30 a.m. to 1 p.m. we have Dr. Amod Kumar, who is principal chief scientist in CSIO, and he'll be telling you about intelligent instrumentation. And in the afternoon, the same day, we have a lecture on industrial drives by Mrs. Shimi SL, who is my colleague. On Thursday, again, we have a very interesting lecture on process control automation by Dr. Chatterjee. And at 11:30, Dr. Baban will again be coming and giving you his experiences on his project, Automated Liquid Media Dispensing System. That is basically the role of automation in chemistry, like in medical stream. And on Thursday in the afternoon, we have a lecture on industrial applications of VI by Dr. Mrs. Lini Matthew. On Friday, I'll be giving a lecture on embedded systems and its industrial applications. And then we'll be giving you a demonstration on the robotic arm by one of our students who has designed a robotic arm based on Arduino microcontroller. So this was all about the courses. Before we move further, I would request each center to please give your introduction. I begin with Government Polytechnic, Beed, Maharashtra. Mr. Nilesh Bhonsle, are you there? Government Polytechnic, Beed, Maharashtra.
मैम उनके माइक में प्रॉब्लम आ रही है.
Okay, मैं उनको बता दूंगी माइक में.
मैम मैं उन्हीं से बात कर रहा हूँ.
Okay. There's some problem with the mic in Government Polytechnic, Beed, Maharashtra. So we move on to our next center from Andhra Pradesh, PVP Siddharth Institute of Technology, Vijayawada.
Yes, ma'am.
Good morning.
Good morning, ma'am. Good morning, sir. Good morning, ma'am.
Yes, ma'am.
We are getting the audio and video, ma'am.
Okay. And ma'am, how many participants are there from your center?
As of now, 12, ma'am.
Okay, but otherwise
Yes, ma'am. They will come. They are presently they are in classwork.
So that's no issue. Otherwise, what is the tentative number of your participants total?
25. 25, ma'am.
Okay. Would you like to say something, ma'am? Any particular requirement you have?
No, ma'am. Everything is okay, ma'am.
Okay, thank you, ma'am. Thank you. So now we move on to our next center, Bahara University, Vakna Ghat. Vakna Ghat कहाँ है? हिमाचल है ना? Bahara University, Vakna Ghat. Yes, sir. RD Engineering College. RD Engineering College. Mr. Mohit.
I'm audible.
Yes, sir. We can hear you.
Very good morning to all of you. First, I would like to thank you to give us the opportunity to organize this short-term course on industrial automation. And last year we have organized around 15 such type of courses, and expecting the same in this academic year. These kind of courses are very beneficial for all the participants, and we have around 30 to 35 participants from our college. And thank you very much for giving us this opportunity to host this STC on industrial automation.
Okay. Okay. Thank you, sir. Thank you. Can we go back to Government Polytechnic? MMU, Mulana, Mr. Akhilesh Tripathi.
Very good morning, ma'am. Good morning to my respected Sir, Provisi sir. Thank you sir. I am very much happy. और फॉर्चुनेटली सर बहुत अच्छी बात है, मैं 10 मिनट पहले कॉल ही करने जा रहा था, लेकिन अच्छा हो गया आपको दर्शन हो गए।
त्रिपाठी जी, हमें भी आपके दर्शन में बहुत दिनों बाद।
नहीं सर, हमारा सौभाग्य है। आई एम लकी पर्सन एंड रेस्पेक्टेड मैम, रेस्पेक्टेड रितला मैम and Madam Poonam Syal. I could see so many times in GTI only in rural department. Sir, I want to say one thing.
Sure.
Somebody has asked me last week, Tripathi ji, आप course करवा रहे हो? Then I told them, I am well entitled to get registered over there, to run this course over here, and automatically it is being registered. I got full right to register myself over there. So I am very much lucky, sir. And second thing, sir, since 2000, sir, I am with you. I am full confident that our electrical department will run the program. It has to get the success by the great leadership followed by my ma'am Lini, and earlier the founder member, my sir is there, and till last week I could see him on this stage. So it has to get success. On behalf of my university, I pray to God that by all means this electrical department has to run at most, and my good wishes is there, not only by heart. So sir, I am there with this department by all means. Thank you sir. Good day. Good day.
Thank you.
Thank you, Mr. Akhilesh Tripathi. सर, आपके टेंटेटिव नंबर ऑफ पार्टिसिपेंट्स कितने हैं आपके सेंटर से?
About 50.
Okay, thank you. Government Polytechnic Beed, mic ठीक हुआ.
Can they hear us?
They can hear us. Bhara University Waknaghat. Bhara University Waknaghat. अच्छा,
ये पूछो can they hear us?
but इतना पता कर लो कि if they can
Hear us and see us also.
Okay, as I've come to know that Government Polytechnic Beed Maharashtra and Bhara University Waknaghat have some technical problem in the mic and all, but I can tell you, sir, in case you have any doubt or something, you can also type in there, है ना? So you can just type in some message in case you want to convey anything. So before we try to connect with them, I would like to request our chief guest today, Dr. Chatterjee, to please say a few words.
Thank you, Ritula. Good morning, all of you. Good morning, all the persons who are there, the remote centers, the dear two participants.
Hello.
And there's a person sitting there on the camera, Dr. Leni Matthew, Dr. Poonam Syal, and dear Ritula. This is a wonderful opportunity for me. I don't know, I was not prepared for this inaugural session at all, but Ritula caught hold of me and they were quite surprised that I came before time. So that is a good luck for me also to join you in this session. And I know that Ritula and party led by Dr. Leni Matthew, Poonam Syal and all,
Hello.
They must have done a very wonderful job, and we are going to deliver some good stuff to all of you. And one thing I would like to request all the participants at the remote centers, that they must ask us questions. Without asking questions, without deliberations, without discussions, this kind of medium of teaching will not succeed. So you have to be a participant in it by the heart. From the core of your heart, you must be a participant. Take deep interest in it, and then only the questions will come out. And if you ask us questions, we will also be the gainers. You know, there is a saying that a teacher, a person who cannot do anything, he becomes a teacher. But I don't agree with it. A person who can do everything becomes a teacher. That is my thinking. And a teacher is always improves. He always improves, he or she always improves in contact with good students, because the students will definitely give them opportunity, put them in situations to solve problems, to use their mind and presence of mind and whatnot, intelligence, IQ level, etc., etc., so that they can do some solving of problems, and they can give some kind of solutions to the problem. There could be many solutions, but it is the teacher who gives you the path to understand there are several solutions. Now you choose best out of it. So that is the student's job. A teacher can only felicitate, he cannot make you learn. जैसे घोड़े को जब पानी तक ले जाते हैं ना, पानी हम पिला नहीं सकते, उसको ले जा सकते हैं. The घोड़ा has to take the water, right? Similarly, teacher can take you, they can always guide you, the good teachers, and they will tell you that these are the devices, these are the materials, these are the instructional material, these are the textbooks, the periodicals, etc., etc. That is the particular library where you can get all these. That thing is done by the teacher, a good teacher, effective teacher. But rest of it, the learning has to be done by the students. Don't you agree with it? So you are a learner, and I always say that there is a situation, what we are doing, it is a TL situation, teaching learning situation, right? And teacher does the teaching part, the learner does the more important and the bigger part. And you will agree with me that out of these teaching and learning, teaching has got lesser importance, learning has got more significance and importance. If a teacher is very good, suppose he prepares his lesson wonderfully well, uses good devices, his delivery is good, but no learning has taken place, that is meaningless. That's a wastage of time. You haven't used the time, you have not utilized the time properly. So meaningful teaching will be that wherein learning takes place. So a learner plays a more important role. A learner is nothing but their students. If they want to learn, they have to be vocal, they have to be participative, and they have to generate questions, intelligent questions. No matter if you ask some silly questions also, it doesn't matter at all. But you should have the confidence of asking questions. And once you have that particular habit, that particular confidence level, you will become a learner. And you will try to learn. And that is our motto. That is every good teacher's motto. That is the objective. So I think this automation course, what is the name of the course?
Industrial automation.
Industrial automation. This has been planned for a 5-day course. It's a 1-week course, and Ritula has very elaborately told you the session-wise details of this. You will definitely enjoy the course here. The course material I find is very good, and there are certain good speakers from industry as well. So they will deliver very good stuff to you. But ultimately, the responsibility lies on you. You have to take it, and you have to not only take it, you have to imbibe it, so that you can further disseminate to your students. So that will be the final objective of this. With these words, I would again like to welcome you all for this wonderful course, and I will definitely like to congratulate Lindy Matthew, Dr. Lindy Matthew, and Ritula Thakur, Dr. Poonam, Dr. Shimi has joined us later, and they have done a wonderful job. बहुत मेहनत करी है उन्होंने. ये जो मॉड्यूल होता है ना, इसको बनाने में बहुत टाइम भी लगता है, बहुत मेहनत भी करनी पड़ती है. So I appreciate their efforts, sincere efforts, and I do hope that it will give you sincere learning to take place. Thank you so much.
Thank you so much, sir, for your encouraging words. It's always been a pleasure working under also Chatterjee sir, and whatever we have learned, it is from him only. Now I would request Dr. Mrs. Lindy Matthew to please say a few words.
Good morning to all of you, all the participants in the five centers. Even though we could not see the people at Maharashtra and Wagnagat, hope you people are also listening to us. What Dr. Chatterjee was telling, I only wanted to give more importance to it, that for the learning to happen, the participants should sit there and listen. Okay, so I just wanted that all of your participants should be present in the classes, so that you can take advantage of the various experts who are coming for the various sessions. See, like Professor Chatterjee was telling, we worked very hard last week and all, arranging various experts for the course, for the various lectures. So these lectures has to be useful for you, so that you sit and listen and ask questions and imbibe it, and then pass on to your students. So hope you will have a very wonderful time, and the participants who have come here also, welcome to you also. Hope you will also have a good learning time during this program. Thank you very much.
Thank you, ma'am. Now I request Ma'am Poonam to please introduce herself.
So good morning everyone, and once again I welcome all the participants from all the 5 centers as well as the participants who are attending this course at our institute. And I know that Ma'am Ritula has done a lot of work and have taken up a lot of efforts to design the program and also arrange the experts for various sessions across the different aspects of the industrial automation, and it will be surely a very beneficial to all of you. And all the best to all of you, and I hope that you will have full attendance in all the sessions and you'll be punctual so that you get the maximum information and get illuminated by the talk of the various experts and Ma'am Ritula during this 5-day training program. So all the best.
Thank you, ma'am. Thank you. We also have with us some participants who have come from far-flung areas to attend this course here. Now I would request all of you to please introduce yourself from the college which you have come and which subjects are you teaching. Can you start from
My
there?
name is Siddharth Viskarma. Present time I am teaching in Aryabhat Engineering College, Bagpat.
Aryabhat Engineering College?
Engineering College, Bagpat.
Bagpat near Meerut.
Meerut. Subject teaching in current time microprocessor.
Microprocessor. Which microprocessor are you teaching?
805.
8085.
805.
Myself Hamza Sardeti.
अच्छा आपसे फोन पे बात हुई थी उस दिन.
I come from Integral University.
Integral University, Lucknow.
Integral University.
I had been to that university.
Right now I am teaching electrical machining and parts.
Myself Abhishek Devi. I am from Himachal Institute of Engineering Technology, Himachal, Kangra.
Kangla.
I am teaching Operation Research.
Operation Research. Oh. Okay.
That's power systems.
Myself, Nitin Kumar Sir. I am basically from Bilaspur, Institute of Technology, Guru Ghazidas Central University. It is in Bilaspur.
Bilaspur.
Himachal.
Himachal.
No. Chhattisgarh.
Oh, there is the Bilaspur in Chhattisgarh also. Earlier it was in MP.
The subject area is basically industrial and production engineering.
Industrial and production engineering.
Currently, I am teaching strength of materials from basically from.
So mechanical engineering.
Mechanical.
Both of you are mechanical engineers.
I am from mathematics field.
Basically, we are come here to attend the course on sort optimization techniques in engineering field, but unfortunately that course is not cancelled.
Okay. Optimization techniques. What it was given by which department? Applied science.
So they have accepted us here. But this course, because that course is cancelled.
Yeah. There are not many participants.
But you will get good learning experience here also. Because industrial application is a part of mechanical engineering also.
We have got 9 accident.
Accident?
Actually, we got accident last time.
Oh.
That's why I didn't sit through.
How is easy serious?
Emergency 16.
Emergency?
क्या किसका एक्सीडेंट हो गया?
उनके थ्रू ऑप्टिमाइजेशन का जो कोर्स हो रहा था उनका एक्सीडेंट हो गया।
काइंड ऑफ
Emergency.
Oh.
They got some fractures type.
But you'll not have much difficulty because this course is a general type, industrial automation. So all the topics we have taken are like you'll be able to understand.
Not much of electrical engineering, core electrical
It's not a
engineering.
core electrical engineering, so you'll be able.
Mechanical engineering.
Even in the afternoon, we have a lecture by Dr. Pabla, who is a mechanical engineer.
Engineering, all engineers. It is for all engineers.
Interdisciplinary.
So you will not have.
Okay. So now we'll break for the tea, and we'll come around 11:30. 11:15. 11:15. Morning around.
अच्छा ठीक है 11:30 11:30
Afternoon or जल्दी छोड़ देना.
अच्छा okay
So we'll break for the tea break for around half an hour, and we will assemble again here at 11:15. So please do attend this lecture because Dr. Chatterjee will be taking this it's a very interesting lecture, Introduction to Industrial Automation. So see you all at 11:15.
Sure. Right. Thank you.
Correct? Yes. So now we'll begin with our course with the lecture on Introduction to Industrial Automation by Dr. Chatterjee. Over to you, sir.
Thank you, Ritula. I would like to come to the board, I think. Yeah. Well, the topic is industrial automation, right? And the topic what I am going to take with you is introduction to automation. So you must understand what is automation and how automation is useful in doing anything, in getting anything most effectively, most efficiently. And when we talk of automation, we actually mean automation in industries. That is our objective. You all are engineers, and you all are scientists, you all are technocrats. So we would like to know what is the role of automation in industry. That is the main objective. Now I will try to tell you what is automation first. Automation, whenever I talk of this word, people will understand that it means जो अपने आप हो जाए, स्वचालित. हिंदी में कहते हैं स्वचालित. I hope you understand a little bit of Hindi, all of you. This is northern region, so Hindi is our national language. So I think I will be using some Hindi, so you will not mind it. So swchalit means automated. So when we say that it is automated or automation, there is something, some drive, some force take up the activities of its own. Then it is known as automated or automation. Now, before that, we have to understand three things. One is process, control, and instrumentation. These are the three words, very primitive words, very important and significant words in the field of technology, in the field of industries, in the field of technology. Technologies, right? So that's why we have to understand these three. Now, if I talk of process, can you tell me any one of you, what do you mean by a process? Process से क्या समझते हैं?
Basically, thing from which we will convert input into output.
Well, that is from the mathematical point of view. We are saying, if I ask you the physical definition, it has to be properly defined. What is a process? Anything which happens is based on a process. Anything which takes place which is based on a process. So what is that process? Process is nothing but certain activities, series of activities, in a sequential manner. This is process. Series of activities in a sequential manner. Suppose there are 10 steps, activities or steps, you can also say. Suppose there are 10 steps. Step 1, step 2, step 3, step 4, and so on up to 10. This whole thing is known as a, but as you are saying, this will lead to some output. Every step has got certain input. So mathematically, if you want to represent it, or moreover graphically if you want to represent it, it will be input, process, and so if you have 10 steps or 10 activities, you cannot do, suppose somebody is doing 1 first, then 4, then 2, then 10, then 9, it will not lead to any output. So that process, although it is a process, it does not mean anything. It has got no objective, it has no output, no outcome. So I would say that is a haphazard process. That is known as a process. Although it is a process, but it is a haphazard process. So process, it wants to be, if you want your process to be meaningful, to achieve some output, it has to be sequentially performed. So you can always say process is a series of activities or steps in a sequential manner. To achieve what? Achieve an output. Okay. Correct. Now comes control. Is this point clear? Process is clear. Now comes control. Now why control? What do you mean by control? Control का मतलब क्या होता है? What do you mean by control? हिंदी में कहते हैं नियंत्रण. नियंत्रण, किसी चीज को नियंत्रण करना, नियंत्रित करना is controlling something. Why is it required? क्यों नियंत्रण करना चाहते हैं? I would like to quote an example here. I will always say to these examples, I always say these examples to my students. So suppose you are an elder brother or you are a father. Your son or your younger brother, little younger brother, has gone outside the place where you reside. He has gone to some other city or town for studies. And उधर जाके वो पढ़ने के सिवा सब कुछ करता है. He does everything than studies. So he doesn't study at all, but he does everything others, and finally he fails. So in between, if you have not taken care of your ward, your son or your brother, it's a ward, the ultimate result is fails. So he has not achieved the purpose. He has not gained the objective. So the result was he failed in the end. Instead of that, suppose you are an intelligent man, you are a wise man, you want to keep an eye on your ward. What is he doing? How is he studying? He is out of sight. But he should not be out of mind. Normally what happens? The things out of sight is out of mind. It should not be here. You should always take a track. Keep a track. What is he doing? तो आप बीच में जाके उसको check करते हैं. You check, you see what is he doing. Is he going to the class? Is he doing fair in the class? Is he answering the questions? Is he writing the exams well? Is he getting good marks in the examinations, the term exams, etc., etc. So what is that purpose? To put him on the right track. And once he is put on the right track, his output will be 10. So that is known as नियंत्रण या check या control. तो एक चीज तो आप जो जाके कर रहे हैं, the thing what you are doing there, you are going there and doing it. Why are you doing it? That is known as taking feedback. It is, you have to understand, either you are going personally, or you are telephoning the teacher, or you are asking some of your friends to keep a watch on him. Anyway, so there could be hundreds of ways of taking feedback. But your objective, your main aim is to control the guy, to have a check on the guy, so that he does not do anything which is unfair, and he achieves what he is meant for. जिसके लिए वो गया है वो चीज कर रहा है, तो उसके लिए आपने फीडबैक लिया और आपने फाइनली क्या किया? And finally you did control. So now tell me, how do you define control? You are getting an output.
But it was not up to desired level, then we have to check.
Exactly. Output has no meaning if it is not desired output. So output has to be desired output. If you are not getting a desired output, you are although getting an output, but you are not satisfied with that. कि लड़का 4 बार के इम्तिहान में 2 बार पास हुआ, 2 बार फेल हो गया, so desired नहीं है. So to get it desired, your objective is to get in every exam pass mark. 4 बार अगर exam हुए, all the 4 times he must succeed, he must pass. He should not fail in any of the exams. So that is the desired output. Mathematically, suppose you have an amplifier. This is the model you do for control. This is the input, this is the process, and this is the output. If the output is not desired, you will not like to have this kind of output. Take an example. Suppose this is an amplifier. The process is amplifier. The process is amplifier. So what is the job of an amplifier? To amplify the signal. You are getting some input as signal to the process. If that process, suppose it is a 10 millivolt input, and suppose your output has to be 100 millivolt. So amplifier has amplified it 10 times. Suppose that is your objective, or that is your aim, that is your goal, and you are getting 10 millivolt into 100 millivolt, the process amplifier, and the amplifier is working properly. Do you need a control? You don't need a control. When you don't need a control, you don't need a feedback also. So इस type का जो system होता है, that is also a control system, but it is known as open loop system, where there is no feedback. But suppose due to some reason, some gain, losses, etc., some kind of losses, signal losses, you don't get 100 millivolt here, but you get say 80 millivolt. In that case, you are not satisfied, because your desired output was 100 millivolt, and you could only manage to get 80 millivolts. That means the process is somewhere wrong. You will first check your input. If the input is of proper value, proper magnitude, proper shape, everything, then there is something wrong in the process, and that is why you are not getting the output. And your output is a desired output of 100 millivolt. Since you are not getting it, in that case, you will definitely require control. Is this point clear? So process is there. The process is meant to get a desired output. The desired output is not obtained, you need a control. And for control, you need to have a feedback path. So this will come like this. And that has to be fed back. The error is to be generated, how much is the error, and that is to be given to the process. And the process will then amplify it properly. So my example is, this example is just given to you, that you definitely need a control if you need to have desired output. If the output is not desired, you need a control. If the output is desired, you don't need a control. If you need a control, you have to have a feedback part. If you don't have your control is your output is desired, you don't have feedback, you don't have control. So these two are clear. Then comes instrumentation. Process control instrumentation. Why I am telling you this thing is because they are directly related with automation. What is an instrumentation? क्या समझते हैं instrumentation से आप? What do you mean by instrumentation? And many times it is not a single instrument. It is a scheme. So you can also call it instrumentation. Is this clear? Now tell me, what is instrumentation scheme? It is related with some measurements. Measuring instruments. Now, instruments used for measurements. Instruments used for finally process control. So if you don't have the measurement, how will you control it? Suppose यहाँ पर ये जो मैंने 100 millivolt, 10 millivolt का example दिया. Suppose the 10 millivolt is not measured. How do you know that it is 10 millivolt? It has to be measured, and for measuring you need measuring instrumentation. Similarly, output 100 millivolt, you have to measure it with the help of an instrumentation. And another part of the instrumentation you must have studied is signal processing. Signal processing. This is very, very important. Can you tell me what is signal processing?
Conversion of one type of signal into another, or conversion of, for example, if we are giving a mechanical signal, we want to convert it into an electrical signal. This can be for signal processing, or we apply a mathematical function to any kind of signal, and we generate an output in comparison with that, and we can analyze the output. This can be also done.
That to some extent you are very correct, but you cannot define it like that. Signal processing is that, suppose as I give you, signal is lesser, okay? I want to have it processed to, suppose the signal here is something less, which has to go to the processor, and that processor needs a little higher signal. So you need an amplifier, pre-amplifier here. You need a pre-amplifier here itself. So that is a signal processing. To update the signal. Suppose the signal, another example, suppose the signal has got lot of ripples. You understand ripples? Suppose it is a rectified signal, means DC converted into AC, or say AC converted into DC, rectified, inverted, ulta. So if you, because DC is not available everywhere, in a laboratory, suppose you need a DC signal, what do? You use a rectifier. You take the AC signal, pass it through the rectifier, and get a signal which is almost like DC. But can you tell me that is it pure DC? It will never be pure DC. It will be a pulsating DC. It is something like this. This is a pure DC. And the one, what you are getting is something like this. Something like this. What is this? Pulsating DC. And what is this? Pure DC. The magnitude here from here to here is same. If you have it into frequency domain, the frequency will not change at all. But here, from here to here, a lot of variation in this magnitude, frequency, etc. So this has got some inbuilt frequencies which have come from the alternating current system, AC system. But for all practical purposes, we say that it is a DC signal. Now, if that is fed to the process, this will definitely do something wrong to it. The output will not be desired. It will not be effective. It will not be efficient. It will not give you an accurate result. It will not be precise. So for that also, you need processing, clamping, clipping, etc., etc. Then capacitor you put, filtering. Filtering is a process, which is nothing but a signal processing. Then As I said, two examples have been. One is filtering, another thing is preamplifier stage. Another thing, suppose you need a CRO, you must have used. The CRO, there is a range, particular range, that this particular voltage can be applied. But you need to have a voltage to be measured which is much higher. What do you do? You set the probe to the multiplier range, and 1:100, 1:1000, something like that. So it is decreased and then measured. So that is also a process. So all kinds of things. Suppose you have a digital signal. You have a digital signal. You want to put it in analog form. What will you do? You want to know its analog value. You simply use a D2A converter, digital to analog converter, or else analog to digital converter, A to D. So when you have a digital output, you will use analog to digital converter. When you want to have a digital then analog output, then D2A converter. So that is also a process, signal process. So there could be several examples of signal processing. As I told you, to have that particular signal of particular value, which the process will understand. So you will need two things in the control itself. One is the measurement, and second thing is processing, signal processing. All these two, both these two parts are nothing but a part of this instrumentation scheme. Let me put it small one. You understand? These two are inbuilt in the instrumentation scheme. So instrumentation scheme is nothing but a system which will have measuring system, which will have signal processing system, and which will also have the feedback, etc., etc. So these are the three main elements of an automation system. And when you put all together, it becomes an automation system. It becomes an automation. Now, you have the process, you have the control for which you have feedback and measurement, instrumentation scheme you have to measure it, to signal process it, and further give it to the process. And then again you have measurement at the outside output, and if it is not up to the desired level, you will require a control. So all these things, this control system, process, feedback, instrumentation scheme, when you put together, that becomes one system. And if the objective of that system is to regularize the process and achieve it automatically, it becomes an automation system. Is it clear? Now, what were the process of control? कैसे कैसे ये इसकी उत्पत्ति हुई? थोड़ा सा देखेंगे. And finally, nowadays it is digital control and it is intelligent instrumentation scheme. Up to that we have reached. Now, what was the earlier control system? Can you tell me? Earlier, because जब से ये सभ्यता चली हुई है, हमेशा आदमी ने ये सोचा है कि हमें क्या प्राप्त करना है. What is my objective? उसको किस चीज की जरूरत थी? People used to stay in jungles in the primitive ages, old ages, प्राचीन युग की बात कर रहा हूँ. उस समय न तो कंट्रोल था, न इंस्ट्रूमेंटेशन था. उस समय क्या थी? आदमी था, उसके पास भूख थी, और भूख कैसे वो करता था? वो जंगलों में रहता था. They used to move, even कपड़े भी नहीं होते थे उनके पास. They used to move like animals, and animals की शिकार करके उसकी मांस पर ये रहते थे, जिंदा रहते. But the longevity was there, the human being was there, and they were still had their livelihood. तो उन्होंने क्या किया? पहला चीज जो किया वो किया hunting. They hunted animals. तो hunting में क्या काम किया उन्होंने? They used their muscle power. They used the muscle power. Then came muscle power, मतलब उसके साथ लड़ के भिड़ के जीत के करते थे. उसके बाद they thought कि इनके पास तो वेपन नहीं है. Let me have some weapons. Why because the human being had a grey matter at the back of his head or her head called the brain. उसने उसकी चालना की, उसको उसने यूज किया, and he thought कि I have the brain. The animals have more of brawn. There are two things. One is brain, the other is brawn. तो एनिमल के पास अगर शेर से लड़ने जाएगा तो जीत तो पाएगा नहीं, तो क्या करेगा उसको? अगर उसके पास बल्लम होगा, शेर के पास बल्लम तो है नहीं, उसके पास नाखून है, टीथ है, इसके पास उससे ज्यादा बड़ा औजार है, तलवार है, बल्लम है, एक्सेट्रा एक्सेट्रा, तो जीत पाएगा. So he used his brain to win over the brawn. Imagine, this is how the control has taken place. This is how the different processes are developed. This is how the research has come. तो उसने इस चीज का यूज किया, एंड देन ही थॉट कि इससे नहीं हो सकता है, फायर आर्म चाहिए हमें. पहले तो उसने स्टील शुरू किया, छड़ लिया, लाठी लिया, ऑल दोस थिंग. उससे भी जब वो जीत नहीं पाया कंफर्टेबली, देन ही थॉट कि शार्प वेपन्स होना चाहिए, इससे का डिजाइन. शार्प वेपन्स वाज एन इम्प्रूव्ड वर्जन ऑफ कंट्रोलिंग. देन ही केम अप विद फायर इंस्ट्रूमेंट्स, फायर आर्म्स. बंदूक ले आया या आग लेके आया. पहले आग से एनिमल डरता है, तो आग लेके आया. सो दिस वाज द इम्प्रूवमेंट इन द प्रोसेसेस. ये जो प्रोसेस जिसकी मैं बात कर रहा था, ये 1 2 3 4 10 प्रोसेसेस है या 20 है या 100 है. प्रोसेस को इसमें धीरे 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 इम्प्रूवमेंट लाया, मैग्नीट्यूड बढ़ा दिया, एफिशिएंसी बढ़ा दिया, लॉसेस कम कर दिया, इफेक्टिवनेस. अब जैसे तलवार में धारी नहीं है तो लोहा, लेकिन धार नहीं है, तो इफेक्टिव होगा क्या? नहीं होगा ना. उसको इफेक्टिव बनाया कैसे? उसके अंदर धार का. बंदूक है, बंदूक के अंदर कारतूस ही नहीं है, इफेक्टिव होगा? वो कब इफेक्टिव हो गया? जब उसके अंदर कारतूस आ गया. तो ये जो इफेक्टिवनेस लाया गया या एफिशिएंसी लाई गई या उसका इंप्रूवमेंट किया गया, वो स्टेप्स को इंप्रूव किया. एंड व्हाट इज द प्रोसेस? द प्रोसेस रिमेन सेम, बस इफेक्टिवनेस बढ़ गया, एफिशिएंसी बढ़ गई. तो नेचुरली आउटपुट जो है मोर एंड मोर डिजायर्ड होता है. इज इट ओके? सबसे पहले ये आया जिसको हम बोलते हैं मैनुअल कंट्रोल, मसल पावर यूज किया. Please give me the duster. Are you getting the points what I am trying to tell you? So the processes were control processes were first manual. I have given you the understanding, I have given you the example what was the manual process. Clear? Then came semi-automatic. What was semi-automatic process? Can you give me an example of semi-automatic?
Okay.
A cannon. Okay. Manual process was हाथ से इस चेयर को उठा के यहाँ रख दिया और ड्रैग इट. सेमी-ऑटोमेटिक किसी चीज से इसको बांध के खींचा. You just pull it with the help of a rope. That becomes a semi-automatic process. What is an automatic process? इसको किसी चक्के पे बैठा के ड्राइव लगा दो, it will automatically work. Is it not? Semi-automatic process was one process. This is all mechanical process. Then came electrical process. Now, what is happening? Semi-automatic was also an improved version of manual process, but it was in the mechanical group only. Then people thought, can I use some outside agency or some energy to do it more effective so that my efforts are lesser. तो हमने क्या यूज किया, मोटर का यूज कर दिया, इलेक्ट्रिक ड्राइव लगा दिया, so that became an electrical process, and this was actually electromagnetic process. मतलब when I give electricity to a conductor, that becomes magnet and that attracts the things, the plunger moves and hence my drive starts moving. So I made the electromagnetic controller for the process, which is nothing but electrical. I name it electromagnetic because electricity देने से conductor के अंदर magnetic field आपने generate कर लिया. So it becomes electromagnetic. Then came electronic. Electronic process. देखिए इस मैग्नेटिक एम्पलीफायर है, मरकरी आर्क रेक्टिफायर. Have you seen a mercury arc rectifier, something which is a very good example of electromagnetic control? Electromagnetic control is electric bell. Simple electric bell is also electromagnetic control. A relay is electromagnetic control. Yeah? Is it not? When I give supply to it, it has a open. I mean this switch which is becomes open, or sometimes it is closed. So OC and OD, and it works. So that becomes an electromagnetic control. Okay. Mercury arc rectifier were very long used in thermal power stations for controlling, but the voltage drop was severe in this. I about 10 years back I went to Rajasthan and they were using in state electric substation mercury arc rectifier. 10-15 years. There is an outdated thing. You know what is the voltage drop? 80 volts where the voltage drop, and you are using it as a controller. So your controller doesn't work. It is a failure as a controller. It is the desired output is you never going to achieve. So this also changed. Then came your electronic controllers. Electronic controller में two types का है. One is analog and the other one is digital. Analog controllers. Can you tell me? Process controllers. Amplifiers. पहले device कौन सा बना? Diode, transistors. Is it not? Then came thyristors, diodes, transistors, thyristors. Yes. IGBT, power transistors. MOSFETs, power MOSFETs, etc. So many things. Is it not? पहले ये small rating में है, so diodes, transistors, thyristors, आगे ये power हो गया, etc. But then power transistor, power MOSFET, power diodes, IGBTs, इसकी rating बढ़ती गई. Why? What was the requirement? Transistor, small transistor होता है जिसकी rating आपकी 1 ampere, 220 volt. The power rating is very small. But we went to power transistors. We went to power diodes. Diode is SL100. है ना? बहुत सारे diodes हैं. 1N series diode is there. BY series diode, BY126, BY127, etc. These diodes are small rating diodes. They are only the rectifier diodes. But when I want a power, higher power, why do I need it? Tell me. Need क्या हो गई high power के? Because the machines, the devices which I want to control in the industry are of higher rating. तो एक छोटा सा डायोड या छोटा ट्रांजिस्टर लगा के आप क्या करेंगे? You not be able to control it at all. So you need a higher power rating. So power rated devices were, but they are all analog devices. Then came digital, microprocessor, microcontroller, your PLCs, then PCs, etc. They are all digital devices whose supply is say about 6 volts DC, 5 volt DC, but the output is very small. Now you tell me, can we have a completely digital controller? If you want a process controller, analog can be from lower to higher, lower से लेके higher तक चला गया. If you imagine diode could be of, as I said, 1 ampere, 1.5 ampere, and say 220 volt. That is the rating is very small. And one thyristor could be of megawatt rating. Megawatt rating, इतनी high power rating. But that is also analog. कहने का मतलब ये है कि analog जो आपके electronic controllers बने या devices बने, वो पहले बहुत small rating की होती थी. But what was the rating requirement? The requirement was again to get the desired output. You see how we are going towards automation. That I want to tell you. इसकी आवश्यकता इसलिए हुई कि जब इंडस्ट्री है उसके अंदर आके पहले आपकी इंडस्ट्री में जो स्पीड कंट्रोल होता था उसमें आपका शागे मोटर भी यूज होता था. आजकल होता है कोई शागे मोटर? It is outdated. Then you had that motor generator set. Do you have that type of Lord-Leonard controller? You have it now? No. Why? It is the modernization, it is the effectiveness, it is the power losses, it is the maintenance cost, it is the cost, total cost, वगैरह अगर आप देखते जाएं, all these things. So improvement is taking place because the requirement is different. So if you go for a thyristor, which is a much high power device, and I said one SCR, which is a thyristor, could be of megawatt rating. Could you imagine that? Now, why this was how rating is required? Requirement is there. Where is it used? Can you tell me? Where is it used? High power of say megawatt rating. This device, where are you using? Give me an example.
Electrostatic precipitator.
Electrostatic precipitator is definitely high power, but it is not of megawatt rating. It is there.
In the rectifier of synchronous generators, where we can send excitation to that.
That is not very helpful. You are forgetting DC power, HVDC. HVDC. This is very important. High voltage DC transmission. And nowadays the concept is not HVDC. The concept is EHVDC, extra high voltage DC transmission. Now you will ask me, why so much high voltage is required? Tell me. This, I think, as an electrical engineer, you are all an electrical engineer basically. Some of you are electrical engineers.
Yes.
Okay. The transmission is AC. Basically, it is AC transmission. It is not DC. And we call it as flexible AC transmission. Okay. Flexible AC transmission. High voltage it is. I'm talking of high voltage. What is the advantage? As you go for higher and higher voltage, the current carrying capacity will be reduced. Simple. The current carrying capacity of the conductor through which you are taking the power from one place to another. Transmission means what? You are transmitting the power from place A to place B. You are generating the power at place A, but you are transmitting it to place B, which is high at a high distance. So when you are transmitting through a conductor only you will transmit. So you need to design the conductor where it will be where it should be able to bear that amount much of power. So what is power? Power is nothing, the product of voltage and current and followed by a power factor. Correct? So if the voltage is high, to meet the power, the current has to be less. So current carrying capacity of the conductor reduces by increasing the voltage. So that is why transmission is always done at high voltage, whether it is AC or it is DC. So I am talking of AC first, flexible AC transmission. FACTS, we call it FACTS, flexible AC transmission system, FACTS. This is normal practice. And when you are trying to have DC transmission, why DC transmission? Because the losses will be lesser, the conductor will be only one, the earth can be the return path. So their conductor is reduced, so cost is reduced by half. And as you go for higher voltage, the DC transmission is much cheaper than flexible AC transmission. That's why the transmission part is DC. Only transmission, but distribution. You see, there are three things: generation, transmission, and distribution, and after that, utilization. Generation, transmission, distribution, and utilization. You will generate at 11 kV. Transmit at very high voltage because you want to reduce the losses. I square R loss. जितनी आपकी ये कम होगी उतना ही आपको इकोनॉमिकल और कंडक्टर की साइज भी आपकी छोटी हो जाएगी, इसलिए हाई वोल्टेज. लेकिन डिस्ट्रीब्यूशन जहां पर आप गए हैं, जहां पर आपके कंज्यूमर्स हैं, उसके पहले इसको डिस्ट्रीब्यूशन सबस्टेशन में जाकर फिर इसको स्टेप डाउन करना. यहाँ पर आपने क्या किया? स्टेप अप किया, स्टेप इट अप, देन ट्रांसमिशन के बाद स्टेप डाउन के बाद फर्दर स्टेप डाउन फॉर द यूटिलाइजर्स. आपके घर में तो इतना वोल्टेज आता नहीं है, आपके घर में यू आर डोमेस्टिक यूजर्स. कितनी वोल्टेज आती है आपके घर? 220 volts. So it is from 3 to single phase. Further 440, yes, स्टार कनेक्ट कर देंगे तो फेज टू फेज वोल्टेज 1/3 हो जाएगा, and that is 220 volts something like that, 1/√3 times. तो ये जो प्रोसेस है, इसको प्रोसेस को करने के लिए आपको बहुत सारी डिवाइसेस की आवश्यकता होती है. मैं आपको कह रहा था कि थायरिस्टर मेगावाट रेटिंग कहाँ यूज होती है? वो HVDC ट्रांसमिशन में होती है, बिकॉज द ट्रांसमिशन इज DC but distribution is again AC and generation is also AC. Can you tell me any generation which is DC, which generates DC? Just tell me. So DC generator.
Power plant through turbine, the current will be generated in DC form.
DC form. Well, you have heard of the two terms. One is alternator, which is AC generator. The other is DC generator. So what is this DC generator doing? It is generating DC, isn't it?
Yes.
It is generating DC. But okay, you have said that it is generating DC, and I also agree with it. But try to understand how electricity is generated. It is on the basis of Faraday's laws of electromagnetic induction. So Faraday's laws of electromagnetic induction के हिसाब से DC generate ही नहीं हो सकता. AC generate होगा ना, because there is a flux, moving flux, relatively moving. So it is always AC. So how DC generator is generating DC?
By the help of commutator.
Commutator. So you are doing nothing, but you are rectifying it. So it is not a DC generator. We call it a DC generator. It generates AC only, and we convert it into DC with the help of the commutator. Here, similarly, here DC transmission जो हो रहा है, ट्रांसमिशन जो DC कर दिया हमने, तो पहले तो जनरेट तो 11 के लिए AC हुआ ना, तो हमने कैसे इसको DC में कन्वर्ट कर देंगे? We need to have a power thyristor. Here SCR is required. A rectifier is used, and that has to be a very, very high power device. So there we use megawatt rating thyristors. अब आपने कर दिया DC ट्रांसमिशन, फर्दर डिस्ट्रीब्यूशन में फिर उसको आपको AC में कन्वर्ट करना पड़ेगा. फिर क्या करेंगे? अब तो वो DC आ रहा है, अब इन्वर्टर लगा देंगे. Inverter is again nothing but a bridge. So you are using double bridge. One you are using at the conversion from generation to DC for transmission purpose. Another from transmission to DC, again you are converting into AC. So there also you are using this. So these are the users, very, very important users. They are called thyristors, like SCRs, triacs, diecs, etc. etc. And there are many. Suppose there is a class on thyristors and all, then I'll tell you. But this I wanted to tell you that this is a control processor actually, which is still analog. So high power is also required, low power is also required, but it is still analog in nature. And how about these? Microprocessor, microcontroller, PLCs, PCS, etc. PCs, etc. ये सारे डिजिटल डिवाइसेस हैं. अब ये बताइए कि इसका इनपुट क्या है? डिजिटल इनपुट होगा ना, it will only understand the binary language, it will not understand the other language. तो अगर मैं इससे एनालॉग को कंट्रोल करने लगूं, will it be possible? If you are little bit of knowledge of controllers, you will have one final control element. FCE, final control element. What is this final control element? जब ब्लॉक से आप जिस चीज को कंट्रोल करना चाह रहे हो प्रोसेसर में, उसके अंदर एक डिवाइस होती है, उसको फाइनल कंट्रोल एलिमेंट कहते हैं. वो फाइनल कंट्रोल एलिमेंट जो है, ये भाषा नहीं समझती है. That only understands the analog language. It does not understand digital या binary language, because it will understand 5 volts, 10 volts, 5 amperes, 30 amperes, something like that. These are all analog signals. And this microprocessor, microcontroller, PLC, इनका आउटपुट जो होता है वो इस टाइप होता है, डिजिटल, हाई एंड लो. This will not be understood by the FCE. So again you need what? Conversion, that means D to A converter. So I was just trying to tell you that this alone, although this is a very accurate controller, these are more precise controllers, but it will alone not be able to control finally. The final control element has to get an analog signal, and it is only possible with the help of a D to A converter. Is it clear? So now try to understand that I started with these things, very, very simple thing, that what is going to be the desired output. If by chance you don't require any output which is of desired level, then you don't need any control. But is it possible practically? अगर हमें 30 वोल्ट चाहिए और उस जगह 25 वोल्ट आ रहा है, तो आपको वो मान होगा, उसका मान लेंगे? Not. बोले ये तो 5 वोल्ट का डिफरेंस है, and there is a hell of a lot of difference. 1/6 means about 17% error. You will not accept it. Instead क्या करेंगे आप? उस 5 वोल्ट को मेकअप करने की कोशिश करेंगे, और उस 5 वोल्ट को मेकअप करने के लिए whole lot of these things what I am talking about inbuilt in the system. So वो चीज करने के बाद जब आपका फाइनल कंट्रोल जो आपको वैल्यू है वो आ जाएगी, वो कहलाएगा कंट्रोलर. That will be the controller. It could be anything beyond this. डिजिटल में जो है ये प्रोग्राम्ड कंट्रोलर होते हैं. Program controllers. I hope you understand program controllers. Because whenever you are talking a microprocessor or you are talking a microcontroller, you are going to program it. आप प्रोग्राम कर देंगे, उस प्रोग्राम के हिसाब से मान लीजिए एक एग्जांपल मैं दे रहा हूं कि इस कमरे को आपको 24 डिग्री सेल्सियस पे 24 प्लस माइनस 0.5 डिग्री सेल्सियस इस पे आपको टेम्परेचर मेंटेन करना. मान लीजिए एग्जांपल that you want to control and regulate. There are two things. One is control, another thing is regulate. Regulate करने का मतलब क्या होता है? क्या होता है? Why these two words? Regulator and controller.
Regulator is something that we can
Up and down.
by our
Change करना.
Controller is it will fix the value and put it on that. Regulator is if there is a different value, it will try to change its position and take it to the original. That is regulator. Okay. तो यहाँ पर regulator word मैं इसलिए यूज कर रहा हूँ कि सपोज कर लीजिए बहुत ठंड हो रही है बाहर, तो रूम का टेम्परेचर भी बाहर मान लीजिए 0 डिग्री सेल्सियस हो गया, चंडीगढ़ में हो जाता है, तो यहाँ पर 1 या 2 डिग्री हो जाएगा, या ज़्यादा से ज़्यादा 3 डिग्री हो जाएगा. बाहर 0 डिग्री है, here it is 3 degrees, but you need to have 24 degrees. ये कंट्रोलर नहीं कहलाएगा, ये क्या कहलाएगा? रेगुलेटर कहलाएगा कि उस डिग्री से जाके इसको यहाँ सेट करें. अब ये रेगुलेट करने के लिए आपको एक कंट्रोलर लगाना पड़ेगा. तो आप क्या सोचते हैं यहाँ क्या करेंगे? और चंडीगढ़ का ये एग्जाम्पल मैं दे रहा हूँ कि इसी कमरे के बाहर 45 डिग्री भी हो सकता है, तब भी आपको यही टेम्परेचर चाहिए. एरर इज 0.5 डिग्री सेल्सियस. क्या करेंगे आप? क्या करेंगे? व्हाट विल यू डू? क्या आपने एज एन इंजीनियर क्या आपके मन में आता है? जो आप ऑटोमेशन की बात कर रहे हैं, तो आप क्या करना चाहेंगे यहाँ पर? ऐसे जनरल बताओ ना कि क्या करना चाहेंगे आप? तो क्या करोगे आप? आपको ऑटोमेटिव करना है ना. हाउ विल यू गो अबाउट इट? सपोज यू आर द इंचार्ज एंड आई एम द बॉस. आई टेल यू कि आप इसका कंट्रोलर बना के दीजिए, तो उसके अंदर आप क्या करना चाहोगे? व्हाट विल यू बताओ ना क्या करोगे? एक टेम्परेचर मेजरमेंट सिस्टम नहीं होता, उसको बोलते हैं सेंसर, टेम्परेचर सेंसर, राइट. सबसे पहला आपको जो आवश्यकता होगी that we need temperature sensor which will immediately sense the temperature of the room. Suppose it is X. Now X wants to be, it needs to be increased or it needs to be decreased. दो ही सिचुएशन है. कितना इंक्रीज या डिक्रीज करना है वो नेक्स्ट स्टेप है कि नहीं. तो अगर आपको मान लीजिए कि टेम्परेचर को बढ़ाना है, तो आपके पास क्या जरिया बनता है? टेम्परेचर बढ़ाना है. मान लो फ्रीजिंग पॉइंट आ गया, अब आप 24 डिग्री पे जा रहे हो, 2 डिग्री आ गया और उसको 24 डिग्री पे आपको इंक्रीज करना है. तो लॉजिक क्या बनती है? व्हाट लॉजिक यू विल लाइक टू डू? हीटर, इज इट नॉट? यू लाइक टू हैव अ हीटर. तो वहां पर ऑटोमेटिकली एक हीटर ऑन होना चाहिए कि नहीं? बताओ, 1 या 2 जितनी कैपेसिटी है, हीटर को ऑन करेंगे. आपकी जो एल्गो है वो मैं बता रहा हूँ. आई एम जस्ट टेलिंग यू द एल्गो. उस एल्गो को फिर आप कन्वर्ट करोगे इन सर्किटरी, देन यू विल नीड दिस सेंसर, हीटर, ये सब आपको लिखना पड़ेगा. देन यू हैव टू डिजाइन इट, उसकी रेटिंग देखनी पड़ेगी. देन यू हैव टू मेक अ सर्किट ऑफ इट, दैट बिकम्स अ कंट्रोलर. सिमिलरली सपोज 45 डिग्री सेल्सियस हो रहा है, अब क्या करेंगे आप? एसी ऑन करोगे या कूलर ऑन करोगे, कुछ करोगे ना. तो यू नीड अ हीटर, यू नीड अ कूलर और एसी, and you need a system which senses the temperature of the room, and accordingly a system which will put either the heater on or the cooler on, and finally एक टाइम के बाद वो टेम्परेचर को फिर सेंस करके इसको फिर बंद कर देगा और उसको सस्टेन करेगा. I gave you a very simple example. There could be very very complex examples. This is known as automation. हमने ऑटोमेशन में क्या किया कि लॉजिक को पकड़ा कि हमें क्या चाहिए. व्हाट वाज माय ऑब्जेक्टिव? माय ऑब्जेक्टिव वाज द डिजायर्ड टेम्परेचर ऑफ दिस रेंज. 24.5 भी हो सकता है या 23.5 भी हो सकता है. अगर वहां जाके हमने सेट, वो सेट पॉइंट कहते हैं, उसको क्या बोलते हैं? सेट पॉइंट. मीन्स 24.5 सेट कर देना हमें. उससे नीचे भी नहीं जाना, उससे ऊपर भी नहीं जाना. तो हमने लॉजिक लगाया कि इसको पाने के लिए बाहर का जो टेम्परेचर है, अंदर का जो टेम्परेचर, उसको सेंस करो. सेंस करने के बाद इस डिवाइस को ऑन करो. कितनी देर तक ऑन करेंगे कि ये टेम्परेचर आ जाए, उसके बाद उसको स्विच ऑफ करो और सस्टेन इट. अगर फिर से वो बढ़ने लगे फिर उसको ऑन कर दो. अगर वो फिर से कम होना शुरू करे फिर से हीटर को ऑन करो. लाइक दैट. सो दैट इज नोन एज रेगुलेटर. ठीक है. सो ये मैं आपको इसलिए बता रहा हूँ कि आपके प्रोसेसेस, आपके डिवाइसेस आर देयर. दीज आर, इनको सबको अगर आप जोड़ देंगे, पूरी सर्किट को जोड़ देंगे, दैट बिकम्स द स्कीम. or the system, automated system of temperature controller of this room. Is it clear? एक एग्जाम्पल और देता हूँ आपको कि कब तक क्लास है, what time? 1 बजे. ओके, तुमने तो 1 से पौने 1 बजे छोड़ना है, तो हमने 11:15 छोड़ा. ओके राइट. सपोज करिए आपका एक एग्जाम्पल है कि आपको मोटर है, मोटर को आपको फिक्स स्पीड पे चलाना है. सपोज आई गिव यू एन एग्जाम्पल दैट देयर इज अ मोटर व्हिच इज अ ड्राइव which is being used to do some work, and the objective is to run it at a constant speed of 1000 rpm. तो क्या करेंगे आप, आपके दिमाग में क्या आएगा? Type of motor, suppose DC motor, DC drive. The function of the work, the process is to drag something. Okay? वो सर्कुलर फंक्शन भी हो सकता है, लीनियर भी हो सकता है, लीनियर मोशन और सर्कुलर मोशन दोनों ही हो सकता है. सर्कुलर मोशन में भी मोटर काम करता है, लीनियर में लीनियर मोटर काम करता है. नाउ आई हैव टू कंट्रोल द स्पीड और रेगुलेट द स्पीड ऑफ द ड्राइव, दैट इज नथिंग बट द मोटर. वो क्यों? क्योंकि जो आपका प्रोसेस है उसकी स्पीड जो है या तो घट सकती है सेट स्पीड से, मतलब 1000 आरपीएम से, या कम हो सकती है. सपोज इट गो 1200 आरपीएम, आप क्या करना चाहेंगे? स्पीड को कम करेंगे ड्राइव की, ताकि वो बैक टू 1000 आरपीएम हो. सपोज इट हैज गॉन टू 800 आरपीएम, इन दैट केस यू वुड लाइक टू इंक्रीज द स्पीड ऑफ द ड्राइव so much that it again goes back to the original 1000 rpm. ठीक है, तो इसको करने के लिए आपके पास क्या क्या होना चाहिए? एक तो ड्राइव की स्पीड को सेंस करने के लिए आपको सेंसर है. नेम मी a device which can sense the speed of a drive. Tachometer. Okay. ठीक है, टैकोमीटर को आपको लगा के रखेंगे तो आरपीएम में राइट. लेकिन जब मैं कंट्रोलर की बात कर रहा हूं तो कंट्रोलर तो आपका इलेक्ट्रिकल है. टैको जनरेटर विल बी रिक्वायर्ड. एग्जैक्टली, टैकोमीटर आपने ठीक कहा. टैकोमीटर मेजर्स द स्पीड इन आरपीएम. माइंड इट, टैकोमीटर measures the speed of the drive in RPM, revolutions per minute. Revolution per minute is a mechanical term. It is not an electrical signal. इसका जो आउटपुट है वो इलेक्ट्रिकल नहीं है. तो हमें वो आरपीएम को कन्वर्ट करना पड़ेगा इलेक्ट्रिकल सिग्नल में, क्योंकि हमें तो इलेक्ट्रिकल सिग्नल पे काम करना है ना, उसको हम कंट्रोलर में देंगे. तो हमें टैकोमीटर की जगह क्या यूज करना पड़ेगा? टैको जनरेटर. नाउ व्हाट इज द डिफरेंस बिटवीन टैकोमीटर एंड टैको जनरेटर? व्हाट इज द डिफरेंस?
टैको जनरेटर इज अ टाइप ऑफ
डीसी जनरेटर. ओके, तो है क्या चीज?
It generates voltage proportionate to the speed of the.
That is all right. इसको बोलते क्या है? इंजीनियरिंग टर्म में इन दोनों में क्या फर्क है? What is the difference? I tell you.
A tacho generator can be used in the feedback.
No, feedback. All right. So tacho generator is a transducer, and the tachometer is a sensor. तो माइंड इट, इन सबों को जानने के लिए आपको ये टर्म्स भी जानने होंगे कि a sensor is that device which senses the output in its form only. वो मोटर जो घूम रही है वो आरपीएम में घूम रही है, इसको मैकेनिकल स्पीड बोलते हैं. इट इज रनिंग इन टर्म्स ऑफ मैकेनिकल स्पीड, मैकेनिकल एंगुलर वेलोसिटी, एंड दैट इज मेजर्ड इन रेवोल्यूशन पर मिनट. बट इट इज नॉट एन इलेक्ट्रिकल सिग्नल. हमें जो काम करना है कंट्रोलर में देना है वो इलेक्ट्रिकल सिग्नल लेना है. इसलिए हमें सेंसर से काम नहीं बनेगा. किससे काम बनेगा? ट्रांसड्यूसर से काम बनेगा. एंड द ट्रांसड्यूसर ऑफ टैकोमीटर इज नथिंग बट टैको जनरेटर. इज इट क्लियर? मैं आपको ये एग्जांपल इसलिए दे रहा हूँ ताकि हर चीज आपको क्लियर होता जाए कि क्या है ऑटोमेशन. तब आप एज एन इंजीनियर और एज अ मैथमेटिशियन यू कैन डिजाइन इट. यू कैन ऑल्सो डिजाइन अ कंट्रोलर. राइट? ओके, अब आपको ये पता चल गया. अब मान लीजिए कि स्पीड आरपीएम जो उसकी बढ़ गई है, तो योर ऑब्जेक्टिव इज टू रिड्यूस द आरपीएम. ठीक है ना? तो रिड्यूस आरपीएम करके आप उस प्रोसेसर में भेजना चाहिए.
तो वहां पर क्या करेंगे, वो जो आपको आया वो सिग्नल जो है, पहले जो सिग्नल दे रहा था सेट पॉइंट विच वाज, यहाँ पर टेम्परेचर था, वहां क्या है 1000 आरपीएम, 1000 आरपीएम एंड दिस इज 800 आरपीएम. व्हाट इज द एरर? 200 आरपीएम. 200 आरपीएम को आपको एम्पलीफाई कर देना है, इसको बढ़ा के एक्सेस करना है, ठीक है ना. तो आपको जो वहां ब्रिज लगा होगा थायरिस्टर का, जो कि हम कंट्रोलर की तरह यूज करते हैं, उसकी फायरिंग एंगल को अकॉर्डिंगली चेंज करना पड़ेगा ताकि वो जल्दी जल्दी चलने लगे और उसकी वोल्टेज बढ़ जाए. आउटपुट वोल्टेज जो घट गया था वो बढ़ जाए, इसको बोलते हैं वोल्टेज कंट्रोल. तो जो ही वोल्टेज बढ़ेगा तो मोटर की स्पीड बढ़ जाएगी. कितनी बड़ी, आपने इसको पहले से नाप लिया, 200 आरपीएम. This is automation. You are not doing it anything. You are doing it through a device which you have created, you have designed. So automatic system is that which is a regulator, speed regulator. आप वो रेगुलेट हो रहा है, पहले घट गया फिर वो बढ़ गया, मान लीजिए वो बढ़ा हुआ था तो वो घट गया, मान लीजिए वो घट गया था किसी लोड के हिसाब से घटता बढ़ता है, उसको बढ़ा दो. तो उसको मेंटेन करना या उसको सस्टेन करना is a regulator, and that is nothing but a controller which is doing it automatically. That's why it is automation. एक एग्जांपल मैंने आपको टेम्परेचर ऑटोमेशन का दिया, which was nothing but regulator. तो क्या क्या चीज बताया उसमें, एक आपको चाहिए सेंसर, एक आपको चाहिए हीटर, एक आपको चाहिए कूलर या एसी, whatever it is, and you have to need the switches, A to D converters, totally measurement system, sensor, etc. etc. जब आप उसको पूरी चीज को जोड़ देंगे सर्किटरी में, it becomes a system which is nothing but an automatic system of temperature regulator. Automatic system of temperature regulator. Similarly, automatic system of speed controller. क्या वो डीसी मोटर हो, क्या वो एसी मोटर हो, जैसा आपको आउटपुट चाहिए उस हिसाब से देखें. तो इसके अंदर भी सेमी ऑटोमेटिक भी हो सकता है and 100% ऑटोमेटिक भी हो सकता है. As you go on more and more, the system becomes complex. ठीक है? With this idea at the background, I would like to tell you कि what could be a system. अभी आपको सिस्टम के बारे में पता चल गया ना. तो सिस्टम ज्यादातर जो आप मैथमेटिक्स में पढ़ते हैं, क्या होता है सिस्टम? What is a system? System is nothing but a combination of different devices for performing different set of activities in order to get a particular desired output. If that is obtained automatically, the system becomes automatic. Is it clear? Can you reproduce it? If I ask you, what is an automatic system? मैंने आपको काफी एग्जांपल्स भी दिए हैं, मैंने वो समझाने की कोशिश किया. Suppose I ask you, can you explain me what is an automatic system? How will you define it? बताइए. No, a little louder. It can be a system. It has to be a system. Yes. A system is a combination of different devices and measuring instruments to perform the activities which are said to be the process in sequential manner, and to achieve the desired output. If it automatically performs the steps and get the output, desired output, it becomes an automatic system. Clear? अब कितने प्रकार के सिस्टम हो सकते हैं? Can anybody tell me this? Mathematically. Generally, कितने प्रकार के systems होते हैं? How many systems you have in front of you? Mind it, this is just an introductory lecture. We have lot of complications, that's why a little bit of mathematics मैं आपको बताना चाहूँगा. मैंने आपको introduction बताया ना, ये clear हुआ कि नहीं? Is it clear to you? I would like to tell little bit of mathematics, not much of it. Types of system. You know, one is the linear system, and another is can you define? I think you can very well define it. Linear system and non-linear system. Mathematics man. How do you define a linear system?
We can define it on the graph from the graph. This is a straight line. System which gives a straight line with three that is.
You mean a linear system is this? This is of course a constant. So this up to this is a linear system, right? What do you mean by this?
Means when we increase x, it will proportionally increase the y.
Linearly, right? Okay. Then what is a non-linear system? Suppose I write
Like parabolic, hyperbolic.
y square is equal to 3x square plus 2z plus 5y. y2 is equal to 4x square plus 3z square plus 6y. And the z square is equal to something. What are these equations? Non-linear equations. How do you say that this is a linear system, this is a non-linear system?
In this equation, the curve is always it is a curve. When we draw a graph, it is always a curve.
Okay. When you represent it graphically, it either goes like this, or it goes like this, or it goes like this. Clear? Could be either this, or this, or this. It is a straight line representation. Means the output varies linearly to the output. It does not matter this constant. It is a slope. Slope which matters. ये है ना slope आपका. यहाँ slope से है, यहाँ slope है, यहाँ slope है, यहाँ slope है. Okay. अगर इसमें set of equations आपको दे दें y1, y2, y3, and there are 3 equations. Now mind it, why I am telling you? Because any system can be mathematically represented. इसको बोलते हैं mathematical representation of a system. Now you understand what is a system? पहले system मैंने आपको बताया ना. Any system can be represented mathematically. Now I am trying to mathematically represent a system. Well, I said it could be either a linear system or a non-linear system. So if I write it jargon of equations, that becomes a mathematical representation. किसी भी सिस्टम को मैथमेटिकली रिप्रेजेंट करना चाहें तो उनकी जो पैरामीटर्स हैं, उनकी जो वेरिएंट्स हैं, उनके द्वारा हम उस सिस्टम को बता सकते हैं. सिंपल लैंग्वेज इज दिस. These are nothing. X, Y, and Z are nothing but parameters. And these parameters, like parameters का एग्जांपल दो. Temperature, pressure, velocity, coefficient, etc., etc. इन सब चीजों को मिला के अगर मैं लिखना चाहूं और जितनी इक्वेशंस लिख दूंगा वो सारा कुछ उसकी मैथमेटिकल रिप्रेजेंटेशन में. ठीक है. अब बताइए, जब आप डॉक्टर के पास जाते हैं, when your body is also system. This human body is a system. Your eye is a system. Your hand is a system. Everything is a system. And put together that becomes a body that is also a system. तो अगर आपकी हाथ की बात करें, it is a control system. Eye की बात करें, that is also a control system. Your heart is a separate control system. Your legs are separate control system. क्यों control system? क्योंकि अगर आपको यहाँ पर खजुआता है, irritate होता है, तो आप इस हाथ से लाके ऐसे करते ही नहीं. Why do you do it? Because that is your requirement. यहाँ पर अगर हो रहा है, यहाँ तो नहीं करेंगे. करेंगे क्या? इधर ही करेंगे. How do you do it? Why do you do it? Because your requirement is placed. Suppose कर लीजिए आपको प्यास बहुत लगी है, आप सोना चाहेंगे या पानी पीना चाहेंगे? पानी पीना चाहेंगे. Suppose you are hungry. What do you like to do? आप पिक्चर देखने जाएंगे या खाना खाने जाएंगे? So that it is always your requirement. That is the desired output. Try to understand. आपको आंख में नींद बहुत आ रही तो आपको ऐसा करेंगे नहीं. You will try to close it. उस तरह किताब को नहीं पढ़ेंगे, चलो बाद में करेंगे. So this is the requirement, and that requirement is nothing but the desired output. उसको पाने के लिए ही सारा कुछ हो रहा है, और उसको अच्छी तरह पाने के लिए अगर आपको बहुत भूख लग रही है और आपको 2 रोटी दे दे, फिर आप मन सोचेंगे यार 4 तो और मिलता तो अच्छा होगा. Because your desired outputs are 4 chapatis, but it has been given to 2 only. What will you like to do? You will ask 2 और दे भाई. तो ये एक आपका कंट्रोल हो गया. Is it okay? तो ये जो सिस्टम है मैथमेटिकली अगर मैं रिप्रेजेंट करूं, इट डिपेंड्स ऑन इट्स नीड. तो कोई तो आपका स्ट्रेट लाइन है, कोई आपका पैराबोला है, कोई आपका हाइपरबोला है, समथिंग लाइक दैट, कुछ भी आएगा. अगर ये भी चीजें ठीक हैं, ये भी उतनी क्लिष्ट नहीं है. सिस्टम्स आर नॉट वेरी डिफिकल्ट. वो जो मैं कह रहा था ना y1 y2 y3 है, z1 z2 z3, अगर आपके पास साइमल्टेनियस इक्वेशंस हैं और 3 अननोन हैं, 3 इक्वेशंस हैं, आपको कोई प्रॉब्लम नहीं. You don't have any problem. The solution is ready. You will try to eliminate one, put that value, eliminate the second, put that value, get the solution. So you get the solution. But अगर ये फॉर्म आ गया आपको, उस समय कैसा आउटपुट आएगा बता सकते हैं? ये रेस्पॉन्स है ना, दिस इज द रेस्पॉन्स. मैथमेटिकल मैन विल रिप्रेजेंट मोर. दिस इज नथिंग बट आउटपुट रेस्पॉन्स. ये सिस्टम का आउटपुट रेस्पॉन्स ऐसे है. अगर ऐसा सिस्टम आ जाए, उसका आउटपुट रेस्पॉन्स शायद ऐसा हो जाए. नाउ टेल मी, इसको आप आसानी से हैंडल कर सकते हैं या इन समों को? What is that problem which has come here? What is that problem? It is the degree of non-linearity. This is very, very important. Degree of non-linearity. Here the non-linearity is there, but the degree is very, very simple. 1 degree. यहाँ पर आपका जितना ये पावर बढ़ता जाएगा, इक्वेशंस आप जितनी मर्जी लगा लीजिए, आप सोल्यूशन नहीं कर पाएंगे. इसी तरह आपका dy by dx आ जाए या d2y by dx स्क्वायर आ जाए, सो ऑन. ये आपकी नॉन लिनियरिटी, ये आपकी डिफरेंशियल इक्वेशन आ गई. उसमें भी डिग्री ऑफ नॉन लिनियरिटी बढ़ता है. सो द सिस्टम is represented mathematically, no doubt, but it becomes very, very complex if the degree of non-linearity is. और उसको सॉल्व करना बहुत कठिन होता है. और ऐसे चीज को अगर आप ऑटोमेटिक कंट्रोलर बनाना चाहें, ऑटोमेटिक करना चाहें, तो आपके पास खोपड़ी खाली हो जाएगी. This is the job of instrumentation engineer. This is the job of a mathematician who will tell how the system is to be designed. किस तरीके से ऑटोमेटिक करेंगे. एक था कि हमने सिर्फ मैथमेटिकली इसको सेंस किया, 24 डिग्री सेल्सियस सेंस किया और उस हिसाब से उसको कर दिया, जो मैंने आपको एग्जांपल दिया, या 1000 आरपीएम को सेंस किया, अकॉर्डिंगली उससे कंट्रोल किया. मान लीजिए कभी तो 24 हो रहा है, कभी वो हमारा सेट पॉइंट 23 है, कभी 22 है, तो फ्लक्चुएटिंग है. उसको ऑटोमेटिक बनाना इज वेरी, वेरी डिफिकल्ट. जैसे आपकी बॉडी में है, जब आप जाते हैं डॉक्टर के पास, तो डॉक्टर आपकी स्टेटस को समझने की कोशिश करता है. He knows that due to some reason your body, which is nothing but a system, has gone out of order. वो क्या करता है आपको? What does he do? ये आँख देखता है, पल्स देखता है, आला लगाता है, टेम्परेचर देखता है, and then he writes some recommend some prescription. उसमें वो 3-4 चीजें लगा देता है, ये नहीं तो वो नहीं तो वो. So he uses permutation combination. Here also you have to use certain permutation and combination जिससे कि सटीक आपका ऑटोमेटिक कंट्रोलर बने. Because there are, my friend will agree with me, there are certain differential equations and partial differential equations whose solutions are not known. मैंने जब पीएचडी करी थी तो मेरे जमाने में टीसीडीबी डिवाइस पे ऊपर में 40 पेज का डिफरेंशियल इक्वेशन का सॉल्व भी नहीं हुआ. तो कैसे करेंगे उसका सॉल्यूशन? हाउ विल यू डू इट? नहीं हो रहा सॉल्यूशन. देन हाउ डू यू डू इट? मैथमेटिकली मैं कर नहीं पाऊंगा. अगर करूंगा तो मुझे 10 साल लगे. 10 ईयर से एक इक्वेशन सॉल्व कर रहे हैं, इट डज नॉट मीन एनीथिंग. व्हाट टू डू? हाउ टू गेट द सॉल्यूशन देन? न्यूमेरिकल एनालिसिस, दैट्स इट. So there are different numerical techniques, numerical analysis techniques, by which you will do some iterations and you will try to perturb. आप उसको कन्वर्ज करने की कोशिश करते हैं और एक पर्टिकुलर एरर के बाद आप थम जाते हैं. 1000 iterations epoch बोलते हैं ना, epoch. So 1000 after 1000 epoch, I get say 0.05% error. I agree with it. चलो ठीक. तो इसको कहते हैं status finding. Status finding you can do mathematically by knowing its status in terms of mathematics, then develop the equations, develop the system, develop computer programming or algorithm, and accordingly use numerical analysis methods so that you can get the status. If you know the status, then only the controller can be done. Why I am telling you this thing is because automatic controller बनाने में आपको थोड़ी सी मैथमेटिक्स की आवश्यकता होगी, थोड़ी सी नहीं, जितना कॉम्प्लेक्स होता जाएगा ज्यादा से ज्यादा. So mathematical person along with instrumentation engineer make a very good combination of automation. They make a very good combination of automation. अगर आपको automatics बनाने हैं, because it is an introductory lecture, that's why I'm not going in detail. Otherwise तो मैं आपको इतनी mathematics बता सकता हूँ, इतनी complicated चीजें भी बता सकता हूँ कि आप तब enjoy करेंगे. Yes, what is automation? It is an introductory lecture. So I gave some examples, 2-3 examples I gave example of heuristic also. But the degree of integrity, your non-linearity, is very, very important. Because as the degree of non-linearity goes higher and higher, the situation becomes very, very complex. Out of order. जब out of order होगा तो उसको कैसे आप कंट्रोल करेंगे? जब complex medical cases आ जाते हैं, तो क्या बोलता है भैया PGI ले जाओ? Because it is out of his bounds. He is not in a position to know the status. ये क्यों हो रहा है? Temperature बार-बार क्यों आ रहा है? तो जाके PGI में बहुत कुछ टेस्ट वेस्ट करता है और higher rates और this that, and then they come to know that this happens. Similarly, machine is nothing but like that. If you want to know the status of the machine, you have to know all these things. Degree of कितना है, 0 degree है. Then you have to know transfer functions. They convert it into frequency domain. Then know its frequency response. उसके बाद आपको controller बनता है. So my dear friends, don't think that automation is a very simple task. Automation is the most difficult task of engineering because lot of mathematics is involved. And that is why I wanted to give you this particular example. That a status of the machine, who you want to control, could be of very, very high complex nature. High degree of non-linearity. Linear things, no problem. Y1 is equal to this, Y2 is equal to this, Y3 is equal to this, find out Y1, Y2, Y3. So once you know the variables, temperature पता चल गया, pressure पता चल गया, angular velocity पता चल गया, आप उसे solve करो. But if it is y square, y cube, y to the power 4 and so on, higher the degrees, non-integral, this non-linearity is much higher, and in that case the design of automation is very, very tough. So in the next classes I hope the speakers will tell you how to go in for the detailed design of automatic systems. I have given them just introductory of what is an automation, from a very simple example to a very complicated example, and told them how mathematically you can represent what is the degree of non-linearity, how automation will come into picture, right? So, any questions you want to ask?
Center se puch lete.
Yes. So with these words, I would like to thank you all.
We'll ask from each center. Government Polytechnic Beed se ho gaya tha?
Yes, sir.
Government Polytechnic Beed. Do you have any queries from Dr. Chatterjee?
Hello.
Yes, sir.
Hello.
Yes, sir. बताइए, हमें आवाज आ रही है आपकी.
Okay. No problem. It's okay, ma'am.
Okay. MMU Mulana.
No queries, ma'am. Thank you. It was a nice lecture.
RD Engineering College Ghaziabad. RD Engineering College Ghaziabad. मुझे लिस्ट भी दे दो. Mr. Mohit, I cannot see any participant. Mr. Mohit? No, I'll have to call him. This is not right. और लिस्ट दिखाना मुझे.
SP Andhra Pradesh.
SP Vijayawada. PV Vijayawada, Andhra Pradesh. Yes, ma'am. Any queries?
No, ma'am.
Okay. Vaknaghat. Bara University, Vaknaghat.
It's nice lecture, ma'am.
Okay, we
Go
have
for it.
one more lecture of Dr. Chatterjee.
Okay.
That will be a more advanced one. Like he has told you the basic today, process control instrumentation. It will be more advanced one. Or koi center? Okay. So I would like to thank Dr. Chatterjee, who has spared his valuable time and come here for delivering this very excellent lecture on basics of industrial instrumentation. I hope all of you could reap benefited from the experiences of sir. Thanks a lot, sir.
Thank you. Thank you very much.
इधर बैठा मेरे को कोई बुरा नहीं आता बुरा नहीं आता कोई यार की बात है
पूछ रहा हूँ कुछ।
Yes, sir.
Very good afternoon to all of you. So we are ready for our next lecture, that is on automation in industries. This lecture will be given by Dr. B.S. Pabla. He's just on the way, will be arriving here in another 2 minutes. I request all the nodal centers to please be ready with your participants. Yes. So we have with us Dr. B.S. Pabla. He is a professor in Mechanical Engineering Department. He has a vast experience in the field of automation in industries, and I hope that today you will be benefited from his experience. And I request all the nodal centers to please participate and keep asking questions. That will make the whole interaction very lively. Okay. Thank you, sir. Over to you.
Thank you, Ms. Shukla. As she said, I'm a mechanical engineer, so I'll talk more of mechanical engineering related to automation. Well, friends, first of all, I welcome you all to the second session of the day. on the program on industrial automation. Now, before we start talking on automation, let us see what is engineering. Why do we need engineers in society? Engineers we need in society to make the working of human beings as a whole simpler. We have to contribute somewhere so that we can reduce the work of human beings, we can make it easier. Maybe we can eliminate some of the work. That without doing that work, we can do that. I normally give one example of washing machine. We have been washing clothes since very long time. What we call it is science since the times immemorial, and we have been squeezing them to take out water to dry them. But then somebody thought that we have a very simple principle of centrifugal force. If you rotate something, the lighter particles and heavier particles will separate out. So we came out with a washing machine and a dryer. Just see how simple it is now to dry the clothes and wash the clothes. By application of basic principles of sciences, basic physics principles of physics and chemistry, if we can simplify the things for human beings, that is engineering. And if you try to relate it with my topic today, automation is also the same thing. Automation is basically inbuilt into engineering. We have to automate things so that we can reduce the work content, intervention of the human beings into the day-to-day working or in the problem solving or in the day-to-day operation of equipment. Now let's say what is automation. This is my definition, this is not a standard definition. So automation can be defined as any development that may reduce the human intervention in any job. Very generic definition. It can be hardware automation, it can be a software automation. When we talk of industrial automation, we should not forget that we many times talk of office automation also. So there we don't have any machines which are working, physically working. You have a computer which is being used in place of a typewriter. So that is also automation. So automation is any development that may reduce the human intervention in any job. Reduce it. Automation may reduce contents of certain jobs. That means it was a very big job, we may have reduced it to some smaller work content, right? We are typing. When we had to change earlier, when we were using the manual typewriters, we had to retype everything. Now what we have done is we just make the corrections in the Word document. So we have automated the things. We have reduced the work content of rewriting. We have reduced the work of reworking on the content, on the subject. Similarly, you can relate it to reworking of your industrial components also. Instead of redoing it, you do some retrofitting, you do some repair, you do something, you add something and make the component working, make the process working again. Right? Combining several jobs into one. We can combine many jobs into one job. That is also automation. And it may wipe out certain jobs. It may wipe off certain jobs. That is why there is many times resistance to automation. Workforce do not want that it should be automated because many of the jobs are being wiped out.
Actually, so there was a movie also on the same similar line.
Okay, madam is saying that there's a movie on similar line.
Yeah, that when this automation just started, so people they resisted that it will just wipe out our job.
Okay, Ritula madam has given a small example. I will give you an example, a real industrial example. I will not name the industry. When CNC machines were introduced in the industry in our area, in Chandigarh area, Now, prior to that, there was a production-linked bonus in the industry. That means if you make, let's say, 25 components on a lathe machine, you don't get anything, you get on your basic salary. But if you, let's say, produce 40 components, you get 10% extra. If you produce 50 components, you get 50% extra of the salary. But then CNC machines were added, work was completely automated, production control was, instead of the operator, it went to the computer, operation went to the computer. So what happened? Machines started producing 100 components instead of 50 or 25, but the worker was not paid anything extra. They were getting basic salary. So the workers went on strike. They said, when I was producing 40 components in the shift, I was getting additional 50% of my salary. Whereas now I am producing 100 components on the machine. So I am getting basic salary only. I am not getting anything extra. So that type of problems are there in automation. I will come to it. So automation may result in reduction in contents of certain jobs, combining several jobs into one, wipe out certain jobs as it is, but at the same time, it may create new avenues, new jobs. I'll just give an example. I was talking about CNC machine. CNC machines have fastened the production. Production rate they have increased, but at the same time, the type of persons required have increased. One person is working on the machine, second is probably doing part programming in a room. Or there was only one person who was looking after the maintenance of a lathe machine. Now lathe machine has become a multidisciplinary object. With CNC machines, it has become a interdisciplinary subject. A mechanical engineer cannot look after the maintenance of CNC machine alone. Now you need an electrical engineer, you need an electronics engineer, you need a computer engineer, you need a mechanical engineer. So it has become a multidisciplinary job, and it has increased the work. It has increased the manpower requirements, and it has probably added value to the work of the persons attending to it. They are more important in the organization than a former technician. Now, these are some of the industry segments I have written. In fact, I have not written, I have taken from the internet. So these are the major industry segments: pharmaceutical, consumables, automotives, material handling, process industries, refineries, chemical industries, food and beverages, pulp and paper. Some of the industries. I am not saying this is the exhaustive list. So these are the areas. These are the segments which are using heavily dependent on automation now. Now, what are the focus areas? Distributed control systems, PLCs, programmable logic controllers, CNCs, computer numerical control machines, embedded systems, measurement equipment, motor control, motion control, and machine vision. All these aspects have been introduced into industry, and they are being widely used in industry. We'll come to it one by one. But at the same time, if you have any question, I have three friends sitting in the studio also, so they can ask question in between also. I have jotted down this. This automation application are basically two types. One is the monitoring, second is the control. Or we can call it as monitoring and control applications. Monitoring is what? Monitoring is that, okay, you see some data, but the system doesn't take any action. Let's say I'll give you a very small example. You have a heating furnace. You want that you should continuously monitor the temperature. So you have put a thermocouple, you have put a measurement system, you have put a DRO also, digital readout system also, and the system continuously gives you the data. That, okay, now the temperature is 700, 750, 760, 780, 790, 800. And I want that I should not allow the temperature to go beyond 800 degrees centigrade. So what happens? As the temperature goes up, there is a person sitting and he switches off the supply to the furnace. So what you are doing? You are doing only the system. What this automation system is doing, it is only control. It is giving you a temperature reading instead of the person going to the furnace and taking the readings. We have automated the process, and the reading is coming probably at my table through some cabling and all, through some instrumentation. What we have done is we have brought the readings of the furnace temperature to my table. I don't have to sit near the furnace. Probably I cannot afford to sit before the furnace because temperature is very high there in that area. And I may not be needed to sit near the furnace because I can do many other things at my table while sitting. So what the system is doing, what the automation system is doing here is, it is only providing me the reading of the temperature. It is not taking any action on the process. So this is a monitoring application. But if I have a system which says that as the temperature reaches 800 degrees, switch off the supply to the furnace. And as it comes down, when it reaches 760 degrees, it should again switch off the power supply to the furnace. So what it has done, what the system has done, it has now control function has been added. Control function has been added, and the system is now taking the readings and controlling this system. So these are the basic two types of applications we divide it into when we talk about control of processes and production systems. Now, basically, when we talk about industrial automation, there are three types of automation. We call it as fixed automation, programmable automation, and flexible automation. Fixed automation is basically, it is like mass production. That means you have automated the process and you are producing the same component again and again. Normally, let's say you take the example of a nut and bolt making, let's say bolt making, screw making machine. Now, screw making machine is an automated machine. Let's say you want to make the head of the screw, heading is done automatically. Ram drill cutting is done automatically. Threading on that screw is done automatically. But limitation is that it can produce only screws, nothing else. That too in a very limited range. 10 मिलीमीटर का स्क्रू बना रहा है, ज्यादा से ज्यादा 12-15 का बना लोगे, उससे ज्यादा नहीं अगर मैंने 25 मिलीमीटर का बनाना, I cannot make on that machine because I have automated it for a particular type of product and with a particular limited variation in the range, right? So fixed automated refers to the use of custom engineered equipment to automate a fixed sequence of processing or assembly operations. Right? This is also called hard automation. It is not a soft-wired, it is a hard-wired automation. And the primary drawbacks are the large initial investment in equipment and the relative inflexibility. Equipment investment is large because we are customizing it to a particular product because we want a customized, what we call it as special purpose machines we want here, but they are relatively inflexible. That means they are flexible within a very short range. Very small flexibility is there. Programmable automation. In programmable automation, the equipment is designed to accommodate a specific class of product changes, and the processing or assembly operations can be changed by modifying the control program. It is basically a soft wired, like in CNC machines you have. Right? Let's say you have a biscuit making oven. Now, different types of biscuits will need different baking time. Right? If I have a system where I can increase or decrease the speed of the conveyor on which biscuits are dried, baked, I have automated it. It is flexible. Right? I have to just change the speed of the conveyor. Or I have to change the temperature of the oven, heating part. It is suited to batch production. Batch production is what? I said mass production earlier. Batch production is where the components come in batches. Where the, let's say you have made, it is not a single component or it is not a bulk component like I talked about nuts and bolts. It is in batches of, let's say, 200, 300, 500 or 1000, but the batches may repeat after long spans of time. It is not that every time you are producing the same thing. You are producing today, now you are producing something, next time you are producing a different component, different batch of component. In programmable automation, reconfiguring the system for a new product is time consuming because it involves reprogramming and setup for machines and new fixtures and tools. It has to be, because the new batch will need new program, new tools, new fixtures. In flexible automation, the equipment is designed to manufacture a variety of products or parts, and very little time is spent on changing from one product to the another. A flexible manufacturing system can be used to manufacture various combinations of products according to any specified schedule. It needs just customization, right? Depending upon what you want to produce. That means when you have very flexible system, it needs a lot of investment, because you keep on increasing the flexibility and specification of the system becomes costlier. Now this is a comparison of automation. It says fixed automation is high demand value, long product life cycle. That means the products you will keep. Product life cycle means from industry point of view. That means the industry will keep getting the order. ऐसा नहीं है कि थोड़े दिनों के बाद उसका demand खत्म हो गई और उसको बंद करना पड़ा. That means you have a product which will be continuously in demand. Advantage क्या है? Maximum efficiency, low unit cost, because you are producing mass production, so per unit cost is low. Large initial investment in flexibility is the disadvantage. Programmable batch production products with different options, flexibility to deal with changes in the product, low unit cost for large batches. If you are producing small batches, because you are investing in changeovers from one product to another product, if there are batch sizes very small, it may not be economical. New product required long setup times, high unit cost relative to fixed automation. Flexible automation, long production rates, varying demand, short product cycles. That means you need to change the products. You don't have a very long-ended demand available. You need to change the product. So flexibility to deal with design variations, customized products. Initial investment is high unit cost relative to fixed and programmable automation, because unit cost is basically what? Unit cost is cost of manufacturing, cost of labor, cost of raw material, and part of the cost of the machine tool also. Because whatever you are purchasing a machine, the cost of that machine also has to be apportioned to the products you are producing. उसकी cost भी वहीं से recover करनी है. जो भी component हम बना रहे हैं, उसकी cost भी तो जो component हम बना रहे हैं, उसकी machine की cost भी उसी में से recover करनी है. Right? So this is production variety versus production volume. A product variety, that means if there's a if you see the lower corner, it is low. It says if production volume is also low and product variety is also low, go for manual production. One or two, दो ही बनाने हैं तो ठीक है, manually बना लो, उसमें ज़्यादा time भी लग जाएगा, कोई बात नहीं. But you cannot invest on a particular type of machine for that. है ना? Similarly, if you see this, if the product volume is high and product variety is high, second is product volume is medium and product variety is high, programmable automation, then flexible automation, then fixed automation is for high volume, what we call it as mass production. Now why to automate? Why should we automate? One is very important. If you see the technical power, that is the financial matter or the manpower matter. If you see the technical aspect, it is real-time process control we have. If we automate, there are chances of, in sophisticated automation, right? There are chances of that we will get a real-time process control.
Errors will be less.
Error, I will come to it. Yeah, that's very good point. That means the system is then dependent on the machine, not on the human beings. You see, human beings have a tendency, they get tired. In the morning, they'll have a very good efficiency. After 2 hours, if you say that their efficiency will reduce, after lunch, they'll start feeling sleepy, or in between, their supervisor will come, their friend will come. So the production rate will not remain the uniform. But in case of automated products, automated production systems, what you get is the production rates. The output is dependent, is controlled by the machine, is controlled by a computer. So it remains uniform. If you know that, if you have planned for 40 components at the end of the shift, you will get 40. Whereas in manual production, non-automated production systems, the system is dependent on the operator. Quality of the product is dependent on the operator. So that factor is taken out. Then you have a real-time process control. Real-time control on the processes. ये नहीं है कि आज वहां पे कुछ गड़बड़ हो गई, आपको पता नहीं कि कौन सी मशीन है ना. You have a networking inside the machine and inside the production system. So the time a particular machine, let's say, break down. As a manager, you know what has happened. You know that particular machine has broken out, and maybe the onward machines will be affected by because you are not producing on a particular machine, the onward machines will be affected by breakdown of that machine. So these automated systems can give you immediate information. Automated information can give you the process data. What are the parameters at which the system is operating, so that you can take a decision, or the process, the automated system itself can take a decision what to do. If the temperature has increased beyond, let's say, 40 degrees, and if we want that the process should continue beyond 40 degrees, it should stop the product, or it should take a corrective action. It can start an cooling system, air conditioning system, air cooling system for the process. If a particular machine has broken down, the automated system, a computerized system, can tell you that, okay, this machine has broken down. Now the way out is that, okay, you immediately outsource some of the products, or there is an alternate route available to me. एक मशीन से, एक प्रोसेस से पहले दूसरे पे जा रहा था, वो तो खराब हो गया. अब मेरे पास क्या रास्ता? Either I stop everything, or I take an alternate route. So it can help us in taking decisions. That is the management part of the system. Reduce human intervention, as you said. Idea is that it should not be human dependent systems. There are advantages. There are advantages of making human intervention lesser, as I said. It doesn't depend on the experience, expertise of the human being. It depends on it is controlled by the computer, the automated system. Of course, computer becomes an integral part of these automation systems. Modern day automation systems. Computer, it may be a inbuilt systems computer, or it may be a central computer which is controlling. As I said, real-time process data I can get. We were talking to a electrical motor manufacturer. He says, we want to manufacture motors which will have a sensor, which will have a sensing system inside the motor, and through Wi-Fi it will be connected to my office in, let's say, Ludhiana. And we will make a system like that continuously in my office in Ludhiana, I will get the feedback that a machine, a motor which I have supplied in Coimbatore, that is going to fail, and I will call the management of that company that you take corrective action, this motor is going to fail now. Right? Reduce human intervention. That means human intervention, instead of intervention, I say human effort has to be reduced. Human effort should be reduced. So there are small examples. I gave you an example of washing machine and dryer. You take the example of a nail cutter. What is the principle used in nail cutter? It is basic lever principle. Effort into effort arm and load into load arm. Simple principle, simple machine. That is also a machine. That is also automation. So you have to reduce the human intervention. Make products at a faster rate. As I said, human intervention, human effort is reduced. You try to combine some processes. You combine to eliminate some processes. And you try to make the components faster. You might do the job faster, let's say. Instead of saying make the component faster, I say you try to make the jobs faster. Right? Produce quality products. And ensure repeatability. You produce quality. Once you have set the parameters, and you have repeatability, so every time you get the same type of product, same dimensions, right? Remote control. You don't have to be sitting at the machine. You can control the process from remote, right? Now you hear many things that okay, you have control of your refrigerator in your mobile. You can have control of your AC in your mobile. So we have automated the process. Multiple parameter control. At a time, you can take input from many sensors and you can control many parameters. Whereas manually, it was not possible to do it many parameters at a time. What we were doing, we were taking one parameter at a time. Because the effect of parameters combined, number of parameters combined on the process may be different when as compared to when you are doing it by one. Integration of devices. You can integrate the systems. You can integrate a number of systems so that if something goes wrong at one place, maybe there are down the line there are other systems which will be affected by that. You can take a simultaneous action on all the things. In fact, you don't have to do it. I, as a person, as a manager, I don't have to do it. The system itself can control. Faster data exchange. Many times, what you want is that you want to transmit data. By manual methods, it was difficult, but now you have automated systems. You have automated systems where the data exchange will be much faster and simultaneously to all the links wherever you want. I'll give you an example. Let's say there was in manufacturing. Let's say some components was being manufactured in an organization, and you get an feedback that the particular dimension is to be changed. So the design people will change that dimension, and by the time it is, let's say, transmitted to the manufacturing people, many more components would have been manufactured by that time with the previous dimensions. So that means the damage has already been done. But in case of a common database, an integrated system, what we do is, once the change has been made by engineering design, it is automatically transmitted to the manufacturing. It is automatically controlled. Why not? Why not automate? They say there is a labor resistance. They say you are eating into our jobs, right? But as I said, it is not really eating the jobs, it is creating jobs also. And these are you are creating value-added jobs where the salaries are higher. Instead of doing pure labor jobs, pure manual work, you are now doing intellectual work and the returns are higher. Cost of upgraded labor, new skill set I said. New skill sets, one is you have to retrain your labor, and second is they start demanding higher salaries. It is their right because they are doing higher level of work, so they should be paid. Initial investment is high. Management of process improvement, that means you have to manage it improvements. Re-engineering may you have to done, all re-engineering means replanning, etc. Now let's say what are the areas where automation is used in industry. Production system monitoring and control. That means the process or the machines in the organization, they are controlled, they are automated, right? It may be the process industry, it may be the manufacturing industry, right? They are all controlled through some means. You see that there was basic automation also earlier, but now when we are talking about automation, it is PLCs, it is microcontrollers, it is computers, right? So we are talking about that type of this automation now. You need what we need. We need complicated system. We need complicated sensors. We need complicated very little time gap between sensing and reporting the data, right? We need automated systems which will imply very little space. We need automation systems which will need very little time to fix on the equipment. We need sensors and transducers which can be embedded into the system. And we need sensors which can interact with each other, and so that corrective action is taken at their end itself. So production system monitoring and control, material handling, a very vast area where automation has been introduced and used. Storage and retrieval, that means storing the material inside the store and retrieving it. Inspection. Computer vision has been used like anything in inspection. It is an in thing actually. जो हम मैनुअल मेट्रोलॉजी करते हैं ना, मेजरमेंट करते हैं, जो मैकेनिकल वाले लोग करते हैं, सारे करते हैं वैसे तो, पर मैकेनिकल वाले लोग मेट्रोलॉजी ज्यादा करते हैं. दैट मैनुअल इंस्पेक्शन इज गोइंग टू बी आउट, obsolete. It is now based on imaging, right? Machine health monitoring and control. Machine health monitoring means what is the health of the machine? How many hours it will run more, right? कितने टाइम के बाद ये खराब हो जाएगी, कितने काम के बाद फलाना बियरिंग खराब हो जाएगा. You have a system. CAD CAM sim functions, integration, that means. Management functions, as I said, let's say you want to plan, you want to plan for inventory, you want to plan for finances, all that has been automated now, right? Let's say I have a scooter making industry. Now when I get an order of, let's say, 100 scooters for a particular type, I have a computer, I have a program which automatically immediately tells me that for making scooter I need 100 scooter, I need 200 tires, out of which 30 are already lying in my store. For 50, I have already given the order, so I need to give order for 20 more. Right? Similarly, for all everything, it tells. For making this scooter, I need this much production capacity on this machine. And the earliest date I want to give it, I can give the 100 scooters is, let's say, 30th of this month. Or it can work backwards. The management can say, I want to give the delivery of these 100 scooters on 25th of this month. So it can work backwards that, okay, do this, give me this capacity on this machine. Right? Now let's say what is done in what has happened in production and process control. CNC machines have come, computer numerical control machines, which has been a major step in automation in industry, in manufacturing industry. You have machines now which can have up to 5 axes, 6 axis control. There are systems which we call it as reconfigurable manufacturing systems. That means instead of having the limited number of fixed number of spindles on the machine, you have number of spindles as per the requirements of the component. If a component needs 2 spindles, machining on 2 faces, have 2 spindles. If you want a component, you have a component which needs 5 spindles, you put 5 spindles on the machine and do simultaneous machining on 5 sides. Then similarly in process control also, you have very accurate control of the processes. It is not manual. It is now based on the automation. As you were saying, the process is set once here and it gets repeated. There is no need of inspection again and again. What you do is you run the process, inspect 1 or 2, 5 components. Once you are satisfied that it is getting repeated, you are getting the required quality, leave the process alone or monitor it from a remote location. So you continuously get the data, and whenever there is something goes wrong, it gives you a signal that take corrective action. Right? So CNC machines, flexible manufacturing systems, computer integrated manufacturing systems, these are the basically results of automation. These are automation. Process control, process parameters monitoring and control. Through that you can do the process controls. You can have interlocking of the systems, that if something stops, the other should stop. You can have redundant systems in the system. That means normally a particular equipment will work, but if something goes wrong with that, you have a redundant system already created into the process, which will take over the work from the system which has gone wrong. Process planning. Process planning is a major task in manufacturing industries. How to make the process? Let's say you want to make a particular component. What is the material required? What are the processes? What are the operations to be done? What are the machines required for doing that? What are the cutting tools required for doing that? What are the process parameters for that? It can give you all the values, it can control all the parameters, it can monitor all the parameters. Right? Machine tool and cutting tool selection, of that is the process parameter monitoring and control. It can do that. Right? Material handling and control. Automated material handling. Movement and control of material. One is that you are handling the material. You are moving the material from one place to another place with the help of conveyors, with the help of robots, with the help of automated guided vehicles, AGV. Actually, we call it as automated guided vehicle system. This is manless, humanless, driverless vehicles. You program them. Part is already through either a color strip or through ultraviolet, right? And you have a vision system on that AGV. I have tried to show a AGV here in this. What you do is you just have a fixed path for them, and you have a control system. But having the path itself is not enough. You have to control where to stop, from where to pick the component, where it will get loaded, where it will get unloaded, what happens if something else comes in front of that, right? So they can have a sensing system, they can have a vision system, they can have sensors, what we call it as proximity sensors, that if something comes within that range, it should stop, right? If they sense that the battery of the AGV has gone down, it automatically goes to the charging system and gets charged. It has a steering control automatically, how to go it. Integration with machine operation and storage. What we do is you use conveyors. Conveyors are for a fixed type of movement where the movement of the component is fixed, that it will go from one machine to other machine to third machine to fourth machine. But where you have, let's say sometimes let's say you have machines 1, 2, 3, there is a backtracking. The component goes to machine 1, machine 5, then machine 2. Then the fixed type of conveyor do not work there. So what you do is you have a separate method. You have a robot, right? You do it manually. You have a robot which will pick up the component and bring it to the machine back, because robot can move. Conveyor has a fixed position. Now it is not that simple what I have said, that okay, you have conveyors, you have robots, you have automated guided vehicle. You have to integrate with the machine operation and storage. You see, when you have this material handling system, there are normally two types of material handling systems in an organization. First is, we call it as primary material handling system. Let's say like a conveyor, it takes from storage to the machine. But when it has reached the machine, either you load it on the machine manually, or you have a secondary material handling system which picks up from the primary material handling system, picks the material from primary material handling system and loads it to the machine. Again, I have very simply said it, that picks up the component from the conveyor and loads it on the machine, or it keeps it in a buffer storage near the machine. But there is a lot of integration to be done in this, foolproof integration. What type of integration? That okay, when the component comes on the conveyor, when it is to be picked up, conveyor should stop. Or you synchronize the speed of the conveyor with the robot. तभी उठा पाएगा. Then when it has to load the component on the machine tool, there should be this such interlocking that the machine spindle should stop, or the slide should stop. When the component has been loaded on the machine, when the loading robot has moved away from this, only then the machine should start, because we have to be careful about the accident, etc. Similarly, when the machine has done its work, and the component has to be unloaded from the machine, one is the system should know that the machine has completed its machining work. Second, then the command should go to the robot, the robot should move, or the gripper should move towards the job and hold the gripper, hold the job. When the gripper has proper hold on the job, then only the job should be left from the machine grip. Right? So that type of integration has to be done. That type of interlocking has to be done. It is all both hardware and software based automation. Storage and retrieval. Normally what you have? Normally what you have in storage and retrieval? You have racks,
Bins.
you have bins, and you have a person or number of persons who do the storing and retrieval. Right? You have bin cards, you have location known to us, or the persons who are working in the store, they are the better judges, they know where it is lying. Now I come to a system where the storage and retrieval of the material in the storage area is through automated vehicles. If you see, there are two racks on both sides, and there is a vehicle moving inside. It is nothing but a robot. There are two types of systems. There can be two types of storage system. One is, we call it as random storage. Second is dedicated storage. In dedicated storage, you assign the locations to material. That a particular material will go into a particular location only. That means your computer knows that this pin will go into a particular location, and when it is received in the store, this vehicle, this automated vehicle, will pick up that pin and put it in a particular location. The other system is random location, random storage system. In random storage system, what happens? Wherever the space is available, the system, this vehicle will keep the material at that place, but at the same time, simultaneously, your database in the computer will be updated that, okay, the pin which was lying at location number 15 is now at 25. Because when you have to pick it up, computer has to know, the system has to know from where it is to pick up. So there are the issues. These are the issues which are connected issues, what to do. Right? Real-time data you have, because there is nothing manual. Computer knows everything, and you know what is the status. And you can integrate it with your purchase systems, with your vendor system. How many you have already ordered? How many are on the way? In pipeline kya material hai? And it can generate, the system, if automated fully, it can generate purchase orders automatically depending upon who are the suppliers. Right? Because there may be different criteria. Sometimes I want to go for a lowest rate. Sometimes I want to go who can supply me the earliest. Depending upon the criteria, depending on the exigency, depending upon the requirement, computer can generate the purchase orders. You have real-time data. As I said, you can integrate with the inventory management system. Automated inspection. Inspection is an important function, right? Inspection is a necessary evil. I don't want to waste time and resources on inspection, but I have to do it. That is why I said it is a necessary evil. Unless I do inspection, I am not very sure what I have produced will be accepted by the suppliers or this vendors, my clients or not. We have been doing inspection. As I said, measurement is going for a major change. From this manual inspection, it is getting through and through, it will get computerized. There is something called, we call it as a 3D scanner. It scans the component and matches with the stored data and gives you where are the variations. And depending upon your prefixed criteria, it can give you whether it is accepted or rejected. You can integrate a robot with this which can segregate the parts. Accepted को एक side पे रख दिया और rejected को दूसरी side पे रख दिया. You don't have to do it. I have seen in Gurgaon, I have seen a system where they had a complete window, car window, sheet metal window, and you see there is a complicated shape. है ना, कहीं से round है, कहीं से cut मरा हुआ है, कहीं से कुछ है. All the dimensions are fed into the computer, and you have a robot which holds the camera, 3D scanner, and they scan the complete window, and within few seconds or minutes, it gives you the complete picture of the complete dimensions of the complete window. And it can give, it is not only measuring, it is telling you the deviations also, where is the variation. सारी variation आ गई, and it knows what is acceptable variation. कि 5 लीटर की हम 5.2 तो करते हैं, 5.3 नहीं करते. जो 5.3 वाला it will find out, tell you that this dimension is beyond acceptance. So it is automated, right? On CMMs were widely used. Coordinate measuring machines. There are 3-axis coordinate measuring machines were widely used, but now the in thing is machine vision, digital inspection. Automated sorting of goods based on good or bad. That means you put an inspection system, put the things on the conveyor, and let the system scan. Let the vision system scan it. Vision system scans, sends the data to the computer. The computer has the inbuilt program into the memory, and it compares with the template. What we want. Depending upon the results of inspection of a particular component, you have a robot in the next stage. It instructs the robot that okay, you pick this component and put it into good components. Put this component and put it into not accepted components. Right? Such as weight, color, or temperature. Let's say you want to simple things. Let's say you want to sort out apples based on the weight or based on the size. You can put an automated system. Right? You can do automated packing. है ना, डिटर्जेंट बना रहा है कोई, उसकी पैकिंग करनी है ना, बॉटल फिलिंग जो है वो पैकिंग करनी है आपने. You have to set the system, you have to automate the system. Instead of a person measuring and weighing it, the system does it, and it does it accurately. It doesn't spoil the system. बाहर नहीं खिलाता उसको. Machine health monitoring and control. What is this? This is basically a maintenance system. That is basically when do we need maintenance? We all have cars. We all have cars, and when my car has run 5,000 kilometers, I take it to the service center and I say इसका engine oil change कर दो, filter change कर दो, है ना? वो कहाँ से आता है? कहाँ से आया वो? How have we decided? That has been based on the experience. That is called preventive maintenance. That means we prevent the machine from failing. उसका नुकसान है एक. 5000 किलोमीटर के बाद मैं मैकेनिक के पास अपने सर्विस सेंटर में अपनी कार लेके चला गया. But if you check the oil, maybe there is some life left in the oil. I can use it, let's say, up to another 1000 kilometers, but I don't use it. क्योंकि मुझे ये लग रहा है that just because I want to save that on the oil change के 6000, मेरी कहीं कार कहीं पे सीज ना हो जाए, मेरी कार ना खराब हो जाए, so that I have to spend more money, right? But there similarly एक तो breakdown maintenance, ये अपनी predictive maintenance, preventive maintenance है. दूसरी होती है breakdown maintenance. Breakdown maintenance होती है कि जब actual breakdown होगी तब हमने उसको change किया, उस component को change किया. उसमें benefit क्या है? You have used the full life of that component जिसको हमने breakdown के बाद use किया. But at the same time your system may suffer, production may suffer. At the same time, when something breaks, it may spoil some other things also. तभी कहते हैं a stitch in time saves 9.
But it will have benefit also, sir, like opportunistic maintenance in case of.
Okay, so one of my friends had said there is something called opportunity maintenance. I'll come to it. So एक तो breakdown maintenance है जिसमें हम पूरी life use करते हैं component की, but उसमें क्या है? We may spoil other things. हमारा प्रोडक्शन में सफर, आई में ब्रेक अदर कंपोनेंट्स, और वो कंपोनेंट मेरे पास नहीं है, आई एम नॉट रेडी फॉर इट, आई डोंट नो व्हेन इट विल फेल. उसको खरीद के लाने में कुछ कितना टाइम लग जाए मेरे पास. दूसरी है जो मैंने बोला प्रिवेंटिव मेंटेनेंस. बट वी हैव मेड अ शेड्यूल बेस्ड ऑन द एक्सपीरियंस, बेस्ड ऑन द सप्लायर conditions who has given me a data that okay, after every 5000 kilometers change this engine oil, after 20,000 kilometers change the gear oil. But at the same time जब मैं तेल चेंज करवाता हूँ, इंजन ऑयल चेंज करवाता हूँ, मेरे मन में ये रहता है कि यार अभी तो चल जाता है, 1000 किलोमीटर हो जाता है, मैं तो वैसे ही पैसे वेस्ट कर रहा हूँ. बट उसकी जगह मेरे मन में डर है. डर क्या है कि अगर मैं नहीं चेंज करता, अगर गाड़ी सीज हो गई कहीं, फिर प्रॉब्लम होगी, right? So that is another strategy for maintenance. Third strategy जो एक before I come to my maintenance system, one of the participants has said there is something called opportunity maintenance. Opportunity maintenance is that when you have opened the machine for a particular repair work, see other sides also, other components also which are likely to fail. That means when you are seeing that a bearing has failed, see if there is another bearing in his which you can replace at the same time. Is there any V belt which can be replaced? That means you have the opportunity. Breakdown तो हुई है machine की, but you have not now opportunity to see other components also. Sorry. Now the maintenance I want to talk is that you want to take advantage of the full life of each component, but at the same time I want to be aware of, I want to be continuously monitoring that okay, I should know that now this bearing will last only 4 hours. ऐसा नहीं कि मैंने 10 घंटे 20 घंटे पहले ही चेंज कर दिया. When I know that this bearing is going to fail after 4 hours, I should be ready for replacing it. Now how will I know it? I have to do something called a condition based monitoring. What is the condition of that bearing? I should be continuously getting it, right? How do I get it? उसकी कंडीशन का मेरे पास तो कोई थर्मोमीटर तो नहीं है लगाने का कि उसकी देख लूंगा टेम्परेचर है कि नहीं है. तो इट हैज टू बी इनडायरेक्ट. इनडायरेक्ट पैरामीटर क्या है? टेम्परेचर, नॉइज, वाइब्रेशन, 3 ही कंपोनेंट है ना. चौथा कई बार हम विस्कोसिटी ऑफ द ऑयल भी देख लेते हैं, लुब्रिकेशन जो है. बट 3 मेजर कंपोनेंट है आपके, टेम्परेचर, vibration and noise. So you have a system which will measure the vibration, which will measure the continuously give you measurement of the vibration amplitude, vibration noise of the machine or the temperature of the component. If we have already calibrated it, कि अगर मेरी वाइब्रेशन का एम्पलीट्यूड 2 मिलीमीटर ज्यादा हो जाता है, इसका मतलब फलाना बेयरिंग गड़बड़ कर रहा है. अगर टेम्परेचर मेरा ज्यादा हो रहा है, इसका मतलब लोड ज्यादा हो गया मशीन के ऊपर कहीं. अगर मोटर का करंट ज्यादा ड्रा होना हो गया तो मेरा सिस्टम कहीं पे गड़बड़ है, ओवरलोड हो रहा है. So what you do is you continuously monitor the data. At the same time, you know what are the conditions under which the system is operating, because you have a sensing system available. So you have real data and you have real time action you can take, and we can monitor the system. We can put the system on alert. We can program the system that if the temperature goes beyond 40 degrees centigrade, it should stop the system, or it should switch on, as I said, the cooling system. Spare parts management. It can help in maintenance, in planning for spare parts. How many you need, so that you don't dump spare parts unnecessarily, and at the same time you don't go out of stock for the components which are required. Depending upon the periodicity of use, the computer can tell you that okay, these are the components you don't need to buy. इसका एक आधा ही रखो क्यों, तो चेंज नहीं हो रहे. These are the components which are frequently being used. उसके ज्यादा रखो स्टॉक में, because we need more of them. ABC analysis से ज्यादा तो वो basically maintenance में ABC analysis नहीं चलता है ना. XYZ analysis कहते हैं, VED analysis कहते हैं, वो चलते हैं उसमें.
In spare part management, I think that according to ABC analysis, we have to put up whatever the spare.
Because ABC may not help. It is basically usage, how quickly you need, right? Integration, integrate database, faster information flow, timely action you can take. I have discussed this. Management functions. These are basically not associated with the shop floor directly, but these affect the shop floor. As I said, when we talk of automation, it is not only hardware, machine tool automation only. It is office automation also we talk. That is also used in industry, right? So production planning and control. What we will make, what products we will have, so that I have maximum benefit, profit. When we will make, what machines we will use, what tools we will use, how many are optimally required. Manpower planning. How much manpower optimally I need? Do I need to have more manpower in a single shift, or I need to have lesser manpower and run the equipment for the 2 shifts? Do I have to manufacture or outsource? What we call it as make or buy decision, right? Do I have to produce it at all or not? Procurement and marketing sales. It can give you data. It can tell you who is the best vendor for supplying a component, depending upon what you want. Whether I am interested in lowest cost or I am interested in faster deliveries. Financial management. It can tell you all the decision taking data. It can give you for the financial management also. I think let us not say thank you yet. We can discuss. One is we can have questions if you want, but I'll start again for 5-10 minutes. Any centers, please have questions. How many centers are there?
We have 5 centers.
5 centers. Okay. Correct to one.
Sir, first of all, sir, MMU Mulana, sir.
MMU Mulana, please. You have any question?
Thank you, sir. Thank you, sir. Thank you, sir.
Any question, this was an overview of automation industry. I have tried to cover all the aspects where automation is needed, and maybe we can have one lecture on each of the topics. Yeah, is it Bharti? Bharti. RD is involved. Welcome, Professor.
Hello. Sir,
Yeah.
thank you very much for a very erudite lecture.
Thank you.
I would like to ask you one thing,
Yes, sir.
and that is there's a lot of controversy between condition-based monitoring, condition-based maintenance management,
Okay.
and planned maintenance management.
Yes,
Now, the biggest problem is that if we have a planned maintenance system, then if we try to integrate condition-based monitoring and condition-based management, it becomes very difficult to have a planning for our parts. Mostly what happens is, in some cases the parts become obsolete and we have to get the parts manufactured at some time, and at a time it is not possible to get them. This is, I'm telling you from my past experience of 35 years in the industry.
Agree.
So how we should integrate it and how we could come out of this situation, I would like you to explain that, sir.
Thank you, Professor. This is a real situation, a real problem you have put in. But we have to see what matters to us. We have to see the cost and benefit analysis.
Very good.
What is the cost of going out of stock? How much does it affect us? Let me complete, Professor.
Yes, sir.
Let us say we go in for condition-based maintenance.
Right.
Now, condition-based maintenance doesn't say that when the part is already likely to break, you start searching for it. Based on your experience, you have the components in storage for condition-based maintenance also. So you have to have a systematic storage policy, systematic inventory management system, or what we call that spare parts control, depending on whatever, irrespective of whatever strategies you are having. I am not saying, nobody says that condition-based maintenance doesn't need inventory.
But the biggest factor of maintenance is to reduce the inventory as much as possible. And this is one of the benefits which is supposed to be coming from condition-based monitoring.
Sir, this maintenance, this condition-based maintenance monitoring will help you in getting the maximum output from the particular component, because you are using the component to the full life, almost full life. Whereas in preventive maintenance, you are throwing the component before it has failed, much before that.
Okay, thank you very much.
Thank you, sir. Thank you for a very good question. और क्वेश्चन कौन सा कॉलेज है? Government Polytechnic from Maharashtra, please. Can I have your feedback? आपकी आवाज नहीं आ रही.
Sir, your mic is again not working.
He says again not working. That means earlier also it was not working. Please take care. Do something. Please do something, because all the efforts you are doing is going waste if you are not able to listen to you.
PVP Institute from Andhra Pradesh.
PVP.
Yes, sir.
Yes.
Sir, my name is Devakar from Mechanical Department.
Welcome.
I would like to add one small thing based on condition-based maintenance.
Yes, sir.
Actually, this condition-based maintenance, we detect the whatever the failure prior to the failure. We detect any problem prior to the failure. So that we can have time to invent or procure any instruments or whatever the materials that are required for us, so that you can reduce the inventory time if you go for CBM.
Thank you. Thank you. That way, you want to say that from the prior experience also we can have benefit.
Yes, yes.
Thank you. Thank you very much.
Thank you. Nothing, sir. Nothing more doubting.
Yes, sir.
Bahara University, Baknagar.
पहले कह रहे थे एक और डाउट है हमें.
Hello.
Hello.
Ji, good evening, sir.
Good evening.
Sir, it was a wonderful lecture. We don't have any doubt.
Oh, thanks a lot.
Thanks a lot, sir.
Thank you. Thank you.
Sir, PVP से doubt.
हाँ, मेरा ख्याल वही. My friends from Andhra had probably some more query or information to be added. RD के कर सकते. चलिए. So any of the colleges who have any queries, please. So if there are no queries, I thank you all for listening to me with patience for 1.5 hours. Even if you have any queries, you can send an email to the coordinator. We will try to attend to your queries. Thank you very much. And we call it a day today, and tomorrow 10 o'clock we will start again. Thank you very much.